Dr. Samba, for joining us again, and we're really looking forward to it.
Thank you very much. You're able to hear me well, right?
Yes, we can hear you perfectly.
Okay, thank you. Are you able to see my, not yet, I guess, see my screen, right? Okay, 1 second. I need to share my screen, 1 second. All right, you able to see my screen?
Yes, we can share.
Thank you. Thank you very much, Tom. I appreciate the opportunity to reach out to really very enthusiastic learners here. I had a wonderful time yesterday. I hope to have today too, and tomorrow also. Yesterday, I introduced you to what's AI, what's the big fuss about it, why it's an opportunity area, what are the examples of AI and its characteristics, how you can develop your own solutions as long as you know how to handle data management, analytics, algorithms, and understanding the nuances of the problem areas. So today I will continue on the same way, but I want to introduce. Yesterday I introduced supervised algorithm, which means you know the outcome and you explain the outcomes. Today I will introduce unsupervised algorithm, which means we don't know the outcome, but we have the data, blob of data. And on top of it, I will also introduce, the neural networks. So remember, statistical learning has done enormous amount of work in supervised algorithm, unsupervised algorithm. And neural networks is a recent development in the last 30 years, 40 years, but more successful recently because of certain developments on two things. One is the data. Now the enormous amount of data is available. The 3 V's, right? The volume, variety, velocity aspects of data is happening today because of the internet and the smart devices around us, smartphones, including little things like smartphones and IoT instruments. So I will cover unsupervised algorithm today and cover the neural networks today. Also, on the way, I'm going to introduce you the Python programming. So I'll take a short time, like maybe 30, 40 minutes, so that when I talk to you about the actual solution executed in Python, you'll say, oh yeah, I understand, like that. Okay, so that's where I want to take you today. Remember, in my understanding is that this is to give you the flavor, this is to give you the exposure, this is to give you, a possibility thinking, that you can also do it. And I indeed feel that you can do it, but I want to take you there. Okay, that's the purpose of this. And so the first thing I want to ask you, just think about this question. In addition to what Tom is putting questions there, I want to ask you a question. What intrigued you? You don't have to answer. If you answer, that's great in the chat area. What intrigued you? What excited you? What possibly confused you yesterday? Is the question clear to you? Just go ahead and in the chat area, just put in your information. What intrigued you? What interested you? What excited you? What confused you possibly? Okay. It's I always do this in my classes. So, just go ahead and, post the messages, please. I would enjoy reading those things, okay, from you. So few things I want to, while this is happening on your side, please don't hesitate to put your positions or opinions. It's okay. It's fun, really. So I told you that prediction and AI can be devastating. People can be put in jail because there is so much. People believe in the scientists, in the data scientists, in the prediction scientists. So that's the reason. So much belief. When they get disappointed, they'll go to court, and the scientists will be brought in. It can happen. And on top of it, I told you yesterday that even governments end up resigning. Dutch government resigned because their algorithm did not do a good job, and nearly 20,000 people were up in arms, and the government ended up resigning last year. It's a truth. Okay. Also, this is exciting because when people got electricity, how exciting it was, right? The same way that excitement is happening today. That's what Andrew Yang says. And all the while, and it is going to create enormous economic value, and it will transform every industry. Of course, healthcare. Okay. Also, we talked about equity. We talked about the differences between all these things. SL, ML, DL, deep learning, reinforcement learning, all those things. I gave you some very interesting examples. These are just chose few things, but there are a lot of things that are already there in the world right now, and it should be exciting for you. So I kind of walked you through all these things. And then from there, I asked you to extract the commonalities of AI applications. Very, very important, right? And that's why it is very fascinating. It will treat everybody. It doesn't matter where they are, whether they are coming from a rich country or poor country, they get the same solution. Isn't it amazing what an American gets, by the virtue of being an American? You are blessed to have a lot of things, right? And every country in the world gets the same thing. That's the beauty of AI, and in their language. Amazing, right? And it is 724. It doesn't matter, right? Whether it rains, shines, night or day, anything, right? It doesn't get emotional like us, right? We human beings can get emotional, but it doesn't. The AI doesn't get emotional. It just becoming very factual to you, trying to help you. It can, and it is. That's what is happening with AI applications, automated, and it's credible based on science, based on all possible knowledge. Imagine, can I have all possible knowledge? Even in one science, I cannot have all possible knowledge, right? But AI, because it is working with the data that is posted into the database, it is working with the latest information on all possible data points, and it can speak any language, as I said, and it doesn't get tired at all. It doesn't complain. Okay, that's the beauty, and everybody gets the same, same level of treatment. Now, we talked about where they differ in terms of statistical learning, machine learning, and how all the integrated data comes into play. Differences in two cultures: prediction culture, where no functional form matters, versus statistician culture, where functional form matters. Every data point matters. They design the data very carefully. And these people don't do that. Come what may, I will take the data, I will work on it, right? That's the attitude that is about the prediction people, because they are under pressure to use the data to make industry solve problems so that they can make money, right? And the whole economy grows and so on. And it was not very popular in the beginning, but now it is, it's not, I would say every statistician cannot, would love to term themselves as data scientists, because what? If you add a data scientist qualification, this is the fact, your salary goes up 20% extra, so everybody wants to call themselves as data scientists. But it's a whole big world is out there. There is the possibility is 2012, 2011, 2012, McKinsey published a document that said that the opportunity of the analytical intelligence, okay, is $5 trillion in the next 15 years. They talked about 2011. The publication came in 2011 by McKinsey, okay? $5 trillion. I say, even if it is only, it's all hype, it's only 10% valid, it's still $500 billion, right? Isn't it amazing? So everybody has a big opportunity here. It doesn't matter whether you want to call it yourself statistician, data scientist, computer science, doesn't matter. As long as you solve problem, there is so much value you can create, okay? So now more and more people accept the data science as the critical resource, and it's a strategic resource for organizations and for governments and people. So we talked about all those things, and the increasing evidence of more and more people are working even in health, and there's a tremendous amount of growth of publication of this publication. This is coming from PubMed publication. So, and I showed you two examples. Every hospital nowadays uses this risk of readmission because they are getting incentivized by the Medicare and other organizations. Okay. This was another example, as just another two classic interesting case studies from health. I brought this on. This is about development of machine learning model using multiple heterogeneous data sources to estimate weekly US suicide fatalities and also interventions I'm not sure whether this is actually used in which department, where, and so on. But I'm talking about specific intervention programs could be devised out of this in the field. Okay. I talked about the differences in many slides. How the statistician statistic learning differ from machine learning activities. Just to give you the perspective, so that you can really see, oh, okay, I can understand now, and so on. With that kind of approach, you can talk to others, and you can also talk about what is meant by AI. What are its characteristics? We talked about that, right? And I was saying, even with all these things, still only 30% of the opportunities are addressed using machine learning. So there's a huge opportunity waiting out there. Okay, even in I'm talking about whole collection of industries, of course, in health also. We are just yet to even scratch the surface. Okay, and I took an example of, okay, if it's a cohort study in health, where does it differ? In terms of the study from statistical learning and machine learning. I talked about all these things yesterday. And the interest became very, very popular 20 years back when Brayman published that, look, random forest can have lower error in prediction. Across the board, he was showing the blue line means good, okay, better. That means lower prediction error. And orange line means higher prediction error. So orange is the single decision tree, and which can be used for supervised algorithm I introduced yesterday. And you can see that uniformly it was beating in multiple data sets. He was showing something like 10, right? 3, 6, 9, 10 data sets, okay? And then I introduced you, after I introduced your decision tree, I helped you, explained how decision tree is, interpreted, and how that forest is built out of many decision trees. And then I told you that there is so much we can do with images. And here is one classic example, that is looking at the eye. Just one single eye picture gives so many of these different varieties of information, and these are highly predictive, right? Of course, when you do this image analysis of eyes, you're talking about lots of data of different people's eyes. Each of those persons' characteristics these are the characteristics that the age, gender, BMI, HbA1c, smoking status, and so on, right? But once you collect all these, just single eye picture, you can put through the machine learning and then actually predict, based on how the blood, flows through the veins in the eye, right? Just the patterns of blood flow can give you these predictive information: gender, the age, smoking, HbA1c, and BMI. It's a beautiful example, and there is more detail about that here. It's highly predictive. You can see that area under the curve is 0.97. I talked about area under the curve yesterday. Okay, I might quickly go through that also. So I said, when you get data, you have to be very careful. Make sure that you understand the background of the data, because that helps you to interpret the model also, and that helps you to do the right analytical strategies, introduce right interpretations, all those things. So here is the simple example of the Galton data, which is what started the regression methods that we all use it. Everybody uses it, and many companies had made tons of money just building regression software. I heard it from the readings of CEOs who were telling those things. See, regression and classification, that's good enough. See, statistical applications were one of the hottest tools that people use in the last 50 years. I would say even not even 50 years, 30 years, 25 to 30 years. Enormous applications. They have used it again, ground everything, grind it using this statistical software. Now, of course, we are talking about ML software, but the same situation is going to happen. So get excited about the possibilities, and leverage these possibilities, enhance your your research work and quality of life. Okay, that's my call to you. And I talked about all these things. I kind of intuitively I applied to you how to think about regression, because it's a fundamental concept, regression classification, how to think about it. I introduced the error concept. I also introduced the loss function, and the loss function is also going to be useful for us in neural networks when I come there too. So that's why I introduced that one, because people use certain terminologies. You've got to get used to that. every science has its own terminologies, and no wonder AI, ML, statistical learning are all having their own terminologies also. In fact, it's very interesting. AI, ML will have same thing, they will call it different. Sometimes they do that, which I don't like it, but doesn't matter. The reality is that that's how people follow their practice, follow their sciences based on their background, because they are coming from, most of the time, they're coming from computer science. So they have new terminologies, new ideas, but they're all the same thing, what they borrow or they use or they see in statistical learning. Nonetheless, we got to know those terminologies. So I introduced loss function. Keep that in mind. Loss function is very, very important. And that loss function changes for every problem, depending upon the outcome that you measure. Okay, remember that. The matrices are also important. It's a combination of math, stat, computer science that come together and use it for the domain of science that you are applying in. Okay, so in our interest now, we took the healthcare in this case. So we will be, we need to be good at the domain. We need to be good at algorithm. We need to be good at data, and we need to be good at the visionary aspects of the project, which may be product development or an application development for healthcare. I told you that one important point I wanted to impress again is that statisticians have done phenomenal work over the last 150 years. They have actually developed so much work. They look into all little details about how the functional forms have to be defined, how the transformations have to be done, how the model has to be built, how to do the computation, how to interpret it, how to do the residual analysis. Many of these things are just a kind of quick rush in the ML. It's not a problem. For them, it's a question of, hey, as long as my prediction is working, why do I really worry about it, right? And they will say, I don't have that much distributional assumptions that statisticians have it, and I'm able to do almost the same work or better under some conditions. And it is true. For image analysis, they can do a phenomenal job, ML people, other than SL, because they don't work in those spaces, right? They don't think about those things. They are very careful people, statisticians, looking at every one of the observation. Even if to lose an observation, they have to explain why they are eliminating it. For ML, that's not a problem. So there are, the cultural issues. That's what the two cultures are all about. And we have to live with that because both have certain advantages. It's not true that one is the most important, the other one is not important. Okay. I hope I have impressed on that one. And I explained to you that the decision tree as well as the logistic function is represents the same from the same picture I'm talking about. This is the age, this is the class, diabetic or not diabetic. And so I talked about using this also the confusion matrix. Remember that, okay? Because I'll be using that all over again today and tomorrow. And then there are different measures that I introduced in addition to the confusion matrix, like precision and recall. Remember that too. Very important thing about number of parameters being used. It is not just the number of parameters, but also the value of the parameters, the square of the parameters. All these things can be part of the phenomenal intelligence or intuition that you can use it to do a better job, so that you don't overfit. And the statisticians have already developed that, and they use under the name of regularization, they use it in machine learning. So this is very important concept, and that's why I, at one point yesterday, I kind of implored that, saying that if you're using R square but not adjusted R square, you should be using only adjusted R square. Okay, so kind of mention that because adjusted R square adjusts for the parameters, which is very important. Okay, otherwise you can just keep on throwing in variables, and then you can build a 100% explainable model in regression. So that's not good, right? You need to adjust for the number of parameters there. But what I'm saying here, regularization, is that it is not only adjusting for the number of parameters, but also the value of the parameters and the square value of the parameters. They have certain behavioral goodness principles for modeling purposes, and that's why they are important. And machine learning people use it, statisticians use it also. So always remember that regularization concept is very important, whether it is machine learning or statistical learning. Okay, for every model you build, you got to use that. Okay, and I talked about AUC. That's why I mentioned that. I recall this one right in the beginning. AUC, area under the curve, the one that is raising very fast in the beginning and then tailing off is the best one, rather than the one that is raising slowly. Okay, so remember that. And the interpretation is that this is the false positive. Okay, this is the true positive. Okay. I'm sorry, this is usually, usually it is the specificity, right? Sometimes they will say specificity and sensitivity, specificity, and this is what it is. False positive is 1 minus true negative. It is not true positive. It looks like that. That's why these are all confusing terms. False positive is 1 minus true negative. All right, so we kind of from here, there are a lot of things, statistician did. We don't want to go into it, because just an introduction. And in summary, statistician were doing a great job designing the data, analyzing the variable, transformations, doing residual analysis, estimating marginal contribution of variables, whether it is suppressed, biased, influenced, and variance inflated. They do all these things. Making sure not to overfit, influential observation, they look at those things also, because an influential observation can destroy a model very easily. Okay, it will completely change its coefficients, and it won't be useful. Okay, even though multicollinearity also will change, but it is useful for prediction. But influential observations is useless for prediction. So they do a great job, but it takes a lot of effort, resources, and just it is hard. So that's where the machine learning comes in play also, because you don't have to worry about how to define features. And I talked about the common principle, 2 common principles in machine learning people to do. One is they do training, validation, and testing as a process of estimating the model, and to verify the goodness of that model, they use bias variance trade-off curve. Okay, so where the bias variance trade-off for the validation set is it's lowest. The moment it is down, it will go down as you increase the number of parameters, which is what the complexity means. Complexity of model is same as number of parameters. As the bias variance curve, the error curve goes down, and then when it starts increasing, just stop. That's the time you have to stop saying that no, that's the best model. Okay. And those are the 2 great principles. That's all they use it again and again. Okay. So I talked about just now that one, and I showed you this example. Where to stop. This is the place to stop. This is the prediction error curve. Model complexity increases as the number of parameters increases. So now I'm ready to do the unsupervised. Okay. Any questions from the yesterday's session? Now, did you put anything here? Let me see. Hello, please all. Okay. Hi. Okay. Active stories and used to make the class interesting. I would appreciate the opportunity to go over the recorded written transcript presentation to consolidate into the same day while it's fresh in our memory. Okay. So,
Dr. Samba, I do have one question. Will there be a demo using R during this presentation?
Today I'm going to use the demo with Python. Is that not with R?
I think that answers their question. Thank you.
Okay. But there is another question that's here. What does warfit mean? Okay, that's a good question. That means, you do a great job. You think you did a great job, because the error is predictive error is less, right? Using the validation set, you saw that prediction error is less. You go and apply to the test data set, which is not used at all, right? But the test data set will not do a good job. That means you have overfit the model. That means you have kind of ground the model to the data. Okay, what you have to train the model. So overfit is a situation when you were the way to test it is that when you go and apply it to the test data set, see, your algorithm is going to be always greedy. Okay, you are going to let the algorithm to be greedy. That is what the process is. Okay, so do better, but you are using it with the training data. But when we take it to the real world, will it do a good job or not? So in general, your training, you are going to do a great job using the training data. But if you take it to the real world, it won't do a good job. Means you are overfitted because you have ground the data too much. You have you are taking little information as a big information to build the model. Okay, but that little information turns out to be specific to the data, trained data. So overfitting is the one way to avoid the overfitting is that's why you keep the test data set. So if it is not doing a good job in the test data set, then you are sure that no, you have done a work fit. Okay, so that's the answer for that one. But if you still need some clarification, we can talk about it. At the end also we have time. So feel free to ask questions here and there. Wonderful. So the way I'm arranging today's lectures or instructions and lectures are, I will go through because we haven't finished the unsupervised algorithm, we'll go through that one, and we'll also go through introduction only to neural networks. And I think last 1 hour will be used for before I go into the actual showcase of an example Python program and see the output, show the output, run it, and so on. I'm going to introduce one more thing, two more things, right? One is Python programming I'm going to introduce. Yes, Python programming I'm going to introduce. Don't worry about it. I'm going to talk to you very simple things so that when I explain the Python program in real case study, oh yeah, I understand. Oh yeah, this like that. I want you to get that. So I will introduce Python programming, very simple Python programming for half an hour or so, okay, to 40 minutes maximum. On top of it, I'm going to introduce you to Colab, Google Colab and Kaggle. What is the benefit of that? You don't have to download any software. You don't have to do anything. You just sign in. I will introduce that. You'll just sign into your Google account and ask for colab.google.com, colab.research.google.com. It will take you to Colab. Everybody has free access to it as long as you have a Google account, right? The other tool I'm going to introduce you is Kaggle. Kaggle gives you both Google and Colab and Kaggle together gives you a lot of case studies, training materials, tutorials. So while Colab is, Google Colab is giving it from the perspective of Google, Kaggle is giving it from the perspective of data scientists, where people compete for projects. There are $100,000 projects. I'll show you later. $150,000 project today. There is a Google project available, right? $150,000 project, and there is a $100,000 project still there, and then another 50,000, 20,000, 30,000, and so on. So the nice thing about it is that people who compete there, who win these awards, they post their solutions. Where else you can get this kind of wonderful, competition level, high quality solutions? Where can you get it? Even in your organization, you cannot get it, right? But Kaggle provides that facility. So now I'm going to merge these things for you, in our way of strategizing using the tools, strategizing using the tools. I'm going to show you how to do that. So that way you got the best of the worlds, right? You can rely on that. The reason why I say that is that you don't have to do any updates. Now, I know I have been working with Anaconda for 5, 6, 7 years, right? And, I have to update all those things. And just today morning, I was trying to do something to get some nice pictures for you guys, right? R. And, it failed because, I didn't use R for a few months. And, there is an update issue that is not properly syncing. That's terrible, isn't it? I'm sorry. That's an experience I'm facing. That is happening not just with R alone, but also, and when I say R, I'm talking about R Studio, right? Not just R alone, but it is a problem, common problem in programming, right? The Anaconda platform, the same situation. Some of the, in fact, I have experienced many of the Stack Overflow, Stack Exchange solutions won't work because those are all older solutions. So the best way to do that is I figured out that use the combination of Kaggle, where you have wonderful data science solutions, case studies, codes, and there are discussions about the codes and so on, and also Colab. Sometimes you don't want to use Kaggle because Kaggle gives you. I'm going in detail, but I'll stop with this statement. That there are some things where you want to use Colab. There are some reasons why you want to use Kaggle, but the combination of those two, you can't beat it. That I stopped there. Okay. So two major problems in unsupervised algorithm is that dimensionality reduction. Big data is all about huge dimensions. Even without big data, statisticians had the problem of a lot of data, right? So how do we reduce the dimensions of the data? Okay, that is one fundamental question. The other one is, how do we make sense of the blob of data? So we have a blob of data, but we don't know, is there anything I can make sense out of it? Are there groups there that are capturing commonality of certain types of observations, right? And oftentimes it is important, especially these, when you are on the exploratory mode, it is very, very important, the unsupervised algorithm. So the starting point is principal component analysis. A better statement for that principal component analysis is that main component analysis. That's what it means. Principal means main, but the thing is, it is talking about main dimensions here. Okay, so 2 dimension, 3 dimension, rather than 10, 100, 200, 5,000. Those are all computationally you can do, but it has to come down to 2 dimension, 3 dimension at best, right? That's what humans understand. Of course, 2 dimension means you can see it in a flat paper. 3 dimension means you still have to rotate it. But the fundamental, strategy in principal component analysis is that your mathematics, finds out the key directions where most of the variance is explained. The key direction, key dimensional direction where most of the variance is explained. But that direction may not be one of the variables in the data. It may be a combination of variables in the data. Okay, that is what principal component analysis is all about. But the extension of principal component analysis is what is called the factor analysis. The factor analysis is the same thing you do under the hidden dimensions. Isn't it fascinating? What is meant by hidden dimension, right? Statisticians, mathematicians, they think in a different level, different world, right? They are saying, look, if you're talking about, understanding psychological effects, right? Or the IQ, for example, we are talking about this in our own terminologies, but foundationally, there is something else going on there, right? We don't know what it is, but we try to explain, express, and compute, capture and compute the intelligence using what in observable data. But inside deep inside it, there may be some other dimension which we want to figure that out. That is what called latent dimension, which is same as what is called the factor analysis. So the same principal component analysis comes also in the latent dimension. So you have a lot more data about, let's say, we captured 50 measurements about psychological tests, right? About individual, about readability, comprehension, visualization, on all those characteristics, and the method, principal component analysis, and its derived and its next level, that is called the hidden principal component. I'm going to call it as a latent principal component analysis, which is same as factor analysis. All these things are done basically with the principle that we want to reduce the dimensions to lower dimensions so that we can express the foundational points that that explains maximum variance in the data. Okay, so remember, I'm going to go back one step now about the whole science of statistics. Science of statistics is all about explaining the locality of the data and explaining the variance in the data. That's it. Fundamentally, that's what it is. Okay, so maybe locality can be lots of different things, median, mode, all those things. But the point is about locality. Locality is where most of the observations are. Where most of the observations are. That is about location of the data. And it could be in multi-dimension or it could be in single dimension, whatever it is, right? The location of the data. The second part is explaining where the maximum variance is. And principal component analysis is it first finds the maximum maximum variance. If you look at this blob of data, this is the variance. You can see that most of the variance is, see, these are all kind of outlying observations, but most of the observations is is going in this direction. That's my point. Okay. Second one is, you can see most of the variance is going in this direction, which is perpendicular to the first direction. Okay. Third dimension is, because it's considered as a third dimension data, I have X, Y, Z, the third dimension, which is perpendicular to the plane that is captured by these two axes, is this perpendicular line, this thick line. Okay. So what was originally here, I am coming here and I am saying, this is not the axis we need to work. This is not the axis we need to work. This is not the axis we need to work. The first main principle, first important axis is this. The next principal axis is this. Principal dimension is this. And third principal dimension is this. This kind of figuring out the information from the point of view of explaining the maximum differences as a priority is principal component analysis. Okay. So in terms of visualization, you can see here that this is what it says. Okay, so mathematics fixes these things. Okay, you don't have to worry about it. That's the beauty of mathematics, right? And computational methods. So and actually, once you do that, you can explain them now. For example, in this particular, example, it's USARS, healthcare related issues, USARS here, and you can see that it's 4-dimension data with the 50 state information, but it comes down to just 2 dimensions. That is whether it is, most of them are violent crimes here, less violent crimes here. This is the urbanized here. This is rural here. That's all. Those 2 dimensions will explain most of the variance. That's what it says. Same thing here in terms of another application. This is called biplot. Okay, we use a PCU in the principal component, first principal component analysis horizontally, second principal component analysis in the vertical direction. This is another one, first principal component analysis horizontally, second principal component analysis in vertically. And the first principal component analysis explains in the total variance in the data, 43% of the variance, 44% of the variance is explained by 1 dimension. That's what it says. But that dimension is not any of the variables, direct variable that you observe, but it's a linear combination of variables. That's what is called the first principal component. First principal component, right? It's a linear combination of all the variables. It's an agriculture, production related explanation here. Okay, so basically, and you can give names for these, dimensions. So that's one of the concerns. In the beginning, also when I was a student, I wasn't really impressed with this, because I was worried about how am I going to interpret and so on. But with the experience you gain, and you can see that. And the other thing I want to tell you is that the third secret about statistics. First secret about statistics is that it's about location of the data, most of the observation. Okay, most of the location of the data. The second secret is that the study is all about explaining variance, right? Even regression is explaining variance, isn't it? Okay. The third one is about statistics is about an approximate science. So don't split hair, with one observation there, 2 observations here and so on. Oh, you said, statisticians are very careful in explaining every observation. It is true when we design the data, with that kind of mindset. But, when you're working with multivariate data, you still have to work with, you still have to accommodate that. It's about most of the observations. It is about maximum information available for us. Okay, those are the 3 fundamental principles of what drives the statistics. Okay, there's some some statement here. Oh, okay, that's from Tom. Thank you, Tom. So that's about principal component analysis, factor analysis, and hidden variable analysis, right? Hidden latent variable analysis, all these things. But there is also one more there. What is called the multidimensional multidimensional studies, right? Not multidimensional. Once again, there is another results about contingency table. Contingency tables also you can do the same thing with contingency tables, which is all about the qualitative data. These are not, when I say PCA and factor analysis, they are not qualitative data. They are all continuous variable data. But you can do the same, PCA type analysis, dimensional reduction, and also the latent variable analysis in qualitative data, which is all contingency table data. Okay, we can do the same thing. Okay, so that's a kind of review about multivariate in general, right? But also that we are getting into what is called the cluster analysis, right? So if you look at this blob of data, you can see that there is a pattern here, that a lot of observations are located here of certain type, and there are a lot of observations of located here. Whether we know whether they are of different type or not, you can say that it must be something different from this, right? In some sense, we don't know what it is, but it must be something different from that. And the same way, this is different from these 2. And how do we identify these groups? Okay, that is the question of cluster analysis. Now, there are many clustering methods. We are going to see that momentarily, but just let me get your attention. Suppose you take away these blue lines here, right? And this blue line here, these are the actual observations. So you could have said, oh, these things, I'm only talking about this, let me tell you what I'm doing. Actually, if I take it out, you might be better understanding that. Okay, so I say, if I take this out, I'll put back later. So maybe visually you can see that, this looks like a kind of group. This looks like a group, maybe this is a group, this is a group. Okay, but that may not be the only group. This can also be this way, another group also. So we don't know how many clusters are there. So that's something open. You have to figure it out by making sure comparing very important information, what is called intra-cluster variance with respect to inter-cluster variance. So intra-cluster means, we are talking about with the variance inside this, okay? The variance inside this in relation to the variance between this cluster and this cluster, this cluster and this cluster, this cluster and this cluster. So that relative variance can guide you in terms of, how many clusters you want to have, you should have, okay? So the issue of, determining the cluster and determining the number of clusters is central problem also in the unsupervised algorithm. There are many algorithms there, for example, k-means algorithm, hierarchical clustering, and I'm going to talk to you, a lot more here, okay? So if you see this one, you see mini batch k-means, affinity propagation, mean shift, spectral clustering, what? I will go through this graph, but hang in there, okay? Agglomerative clustering, this is what, your hierarchical clustering is. It's also called agglomerative because you keep on adding one point at a time and then separate out the clusters. DB scan, very, very interesting, okay? These are all new world ML approaches. Optics, which supports the DB scan. Birch is another method. Gaussian mixture is another method. You can see that there are different data sets here, right? These are all the plot itself tells you different data sets, right? So let's take a look at this one, right? This data set is just a blob of square within that all the points are there, and mini batch. And if you say 3, it will split like this. But look at this one. This one agglomerative is not able to separate out, okay? And DB scan is also not able to separate out. But it has a wonderful application you will see later on. Optics, which works with this one, is also not separated out. Also, you can see, they are all different types of separations here. This is different from this is different from this, and so on, okay? It's a tough one, really, right? But anyway, you have to think about, how you are going to use it and what clustering matters for you. That is very, very important. That's a human decision, okay? This one, for example, it's very easily separable, right? This is, blob here together, this is a blob here, this is a blob here. It's very clear, okay? Even visually, everything is doing it well, and even visually that makes sense. But look at this one. How are we going to separate this one, right? I can predict that, the DB scan will do a very, very good job here. Look at this one, okay? DB scan did it. Spectral clustering also did it. And, the rest of them, also the optics that goes with DB scan did a good job, right? Gaussian mixture also did it, but some of them had difficulties. Okay, so look at this one, okay? This one also is mixed up. This one is mixed up, and this one is also mixed up. Take a look at this one, okay? So there is a big collection of, I spent nearly, in clustering alone, I will spend probably, 4 hours, So I'm giving you a flavor here, okay? Giving you some very main points here. So there's a big collection of data is here. It's an intense collection of more points in the same point. A lot of points here, a lot of points here, but more spread out here and so on. So here you can see that there is some mixture here. Interestingly, it is identifying these are all the outliers. The more dense points are here. That's remember it's about really density here, and this is also about density. They work together. So density, wherever densities are here, it's all clearly more well understood. So this is a density. It's also density, but it is less tolerance, to the outliers that are noise. They are called noise here. It's in the case of the DB scan. Look at this one. Very, very interesting, right? This kind of data, if you get, or this kind of data, if you get, how do you do this clustering, right? These are all kind of one inside the other. You cannot put a line and separate it, right? You cannot put a line here also, same thing. But the method, some of the methods does a phenomenal job. Spectral clustering does a phenomenal job. Also, the DB scan does a phenomenal job. Optics that goes with this does a phenomenal job. But here it's getting mixed up. Here it is getting mixed up. It's mixed up. This is a good job, spectral, and it's some amount of mix up, some amount of mix up. So here is a tough one. Okay, look at this one, right? It can't really figure out. For this data, okay, mini batch is tough. K-means will have tough time. But K-means is a very popular one, commonly used also. Okay, so you have to think about all these details when you are selecting what clustering method you're going to use. That's my point. Okay, So there is no one method, my teacher taught me this, so I'm going to use, it's not going to work out. Okay, think about that. Spectral and DB scan will do a phenomenal job, and they did a phenomenal job, and including agglomerative. Okay, because it's all one point at a time you take it, and they are all together here. So agglomerative did a good job here, but you can see that it's did a poor job at the bottom. We saw that, right? So my point is that there are tons of different methods are there. You have to be careful in selecting and using them. And if you are talking about dense sets, go with spectral DB scan and optics. Okay. If you're talking about the mean spread, the k-means will have the mean spread or median spread, or they call it as medoid, right? Mean spread or median spread. K-means is good, but is that what your problem is supposed to explain? Think about that. Okay. Spectral will do wherever the DB scan does a good job, okay, in general. But DB scan also identifies which one of them are outliers. Okay, within the definition of what you give, the parameters to the DB scan, it will identify the outliers. Okay, so the point I'm trying to impress here is that there are many methods are here, and you have to use you have to carefully select your methods in terms of using for the purpose for which you are designing it. Okay, in this case, it's really about exploration. Remember that. Okay, so you don't have to worry about it. You have to try different things, and it's okay. But the more and more you move towards explanation, which is different from exploration, then you have to think about more careful studies, like talking about the very deep analysis that statistician does, or even the deep analysis machine learning people will do. Okay, so I want to take a look at this one. I want to introduce something which you would not have heard of it, that is called DB scan. Okay, so take a look at this picture here. You can see that there are more dense points are here going in this direction, more dense points are going here, dense points are here, dense points are here, even though the cluster of brown point, the khaki color points are all over here, right? But the density is happening here. Blue points are probably all over here, but then density is here. Green points are all over here, but then density is here. So if you are looking for, for example, if you're looking at an image, let's say, I will recall breast cancer images, right? Where point in the areas where it is problematic, right? Some small dense areas will show. In the picture, it will be a white color, spread out very thickly compared to other regions. Then you can pinpoint using the clustering algorithms. Specifically, I'm talking about DB scan, for example, and there is a case, that I will refer soon. And so what is DB scan? Because it's new, you would not have heard of it. I want to explain that one. So DB scan basically, let me see. DB scan. So this is what the graph that tells you that at the bottom I have the reference about the cancer research. It can identify micro calcification easily, but if you use k-means, k-medoid, Clarence, these are all variations of this method. The usual traditional methods, classic methods, it won't do as good as what the DB scan does. Okay, in terms of efficiency, it is fast enough, but in terms of micro calcification, it does a phenomenal job. Okay, so that is the point there. Noise detection, it also does a good job. Okay, noise detection. In addition to that, it does a good job about micro calcification. The micro calcifications are all very difficult for k-means and k-medoid, all that group of algorithms. Okay, that's why I get interested in this one. There's a question here. I'm going to attend to some in statistics. Is it okay to be slightly overwhelmed with the amount of statistical information? Do you have advice on how to get over this lag? Okay. Today and yesterday and today and tomorrow also I'm going to do this one. I am giving you pointers here and there, and if you catch on those pointers and approach all the problem from that point of view, it should be, in my opinion, it should be much easier. I hope it makes sense what I'm saying. For example, I said, statistics is all about 3 things. Okay, machine learning is all about 2 things, right? Focus from there. Okay, start focusing from there. So, for example, statistics is all about where most of the data are located. First point, right? And then how they are spread, right? How they are spread. Then modeling is all about explaining the most of the location points are, explaining the most of the location points are, and explaining the variance in the data. That's why regression is about, R square is adjusted R square is about percent variance explained. That's once we explain maximum variance, we are satisfied, we are happy. So think from this point of view. I think it will help you. In the machine learning, I said two things. Hey, it's all about really, doing this, split training, validation, testing, and then train the model, validate it, train the model, validate it, and then when you come to the good model, you decide that is a good model based on bias variance trade-off, go and apply it for the test data. And if it comes out to be almost the same, you have done a phenomenal job. Okay, you didn't overfit it, you've done a phenomenal job. That's it. It's machine learning is all about that. Of course, there are different algorithms coming there. But you also have to give some time to learn, one algorithm at a time and work with your group. You will have a team where there is a data scientist there, statistician is there, computational engineer, data engineer is there. You kind of socialize with them. Socialization is very, very important in any subject, right? Socialize with them, learn from them. But there are easier methods. Today, I'm going to introduce you Kaggle and Colab. That is the shortest pathway for you to learn, apply, and develop solutions in Python. Best way. So you have to come to hear these kind of statements also, because this is out of a lot of pain and sweat and tears that people come to this level of statements, right? So you have to work with people, you participate community, socialize with similar people, and draw lines like what I was saying, right? Oh, it's okay, I can do that, and do some work practically. Do a few times, then you more and more you become comfortable. I hope I answered your question. Okay, it is not overwhelming if you work with the right people. Okay, and like, okay, that's something Tom answer. Okay, all right, another question. Yeah, I don't mind. Please go ahead and ask your question. That's fine. I'm happy to hear your questions. Okay, because I enjoy listening to you, what your concerns are, what your worries are. Yes, of course, SK. You won't believe. There are moments in, I would say, I sweat, oh my goodness, how am I going to convince my manager, right? These managers, they may not know strategy, but they know business. They can ask you good questions, right? And you would not think about the business. You will only be, working out with the, training, validation, testing, training, validation, testing. Oh, I got a great job, great model, and you take it there and you will say something, right? So it is. So, and I mean it in a real way, so, but, your enthusiasm, your interest will be the best guide for you, okay? So that will take you where you want to go. But be in the community, be, socialize with the people in your company, and, you'll be fine, every day learn something, you'll be fine, okay? Win every day, remember that, win every day. All right, so let me quickly introduce you to DBScan. See, for example, when I introduce these kind of things, I hope you can get something out of it, right? I'm sure you can't take everything, but you can take some big things and write it down, those 5 things you learned today, something like that, right? Again, you still have to work. There is no easy lunch. So the way DBScan thinks about is, its problem is really to density-based clusters. It is not thinking about center-based clusters. Median-based, mean-based, k-means, medoids, all those things are all center-based, location-based. But DBScan is density-based, how dense they are, right? That's the difference. So how do you measure density? You give any specific circle, right? Or the sphere. In multi-dimension, it is a sphere, right? Circle is, it's a 2-dimension sphere. In the globe type, is in the 3-dimension. Sphere can be thought of in multi-dimension in the same way. Okay, multi-dimension points, how dense they are, how close they are. So if you take a specified circle in a 2-dimension, it is 1 unit. Let's say this is the circle size, radius, right? You have to fix that. That is one parameter you have to fix. So every method has its own, fixing issue, parameter fixing issue. This is one parameter you have to fix. There is another parameter you have to fix. That is how many points, if it falls inside, you will consider as a dense point. Okay. So let us say here I'm saying 1 unit of radius, and I will say let's say 3 points, right? 3 points should be there to call it as a dense point or inside point. If it is not, then it is an outside point. That is, either it can be a boundary point, but it is a noise point if it doesn't include any circle, with a point doesn't include one point, that is called noise. So there are 3 principles I brought in, right? So in terms of density, I'm going to determine the clusters versus in terms of median center-based clusters, okay, location-based clusters. So I move around this one. So I got 3 points here, so it's considered 3 points, and then an EPS is 1. That's the radius. Okay, so it is considered as a here in this case we are talking about more points. Okay, it's not 3 points; it's more points. Okay, so only it is here we have 3 points here. Here you can see that there are more points here, right? The more points could be, it should say what the number of points are. Let me see whether minimum points is 4. That was behind this. So minimum points is 4. In this case, we are talking about minimum points. Okay, so minimum points is 4. If it contains less than 4 points, it is the boundary point. If it doesn't contain a point, for example, these points are noise points. This is not the noise points. Okay, these are the noise points. If it doesn't contain any circle doesn't contain that many points. In this case, 4 points. It is called noise. Otherwise, it can be a border point. Or it can be internal point or this, the dense point. You just collect all the dense point, you got the cluster. That is what the point is here, right? So there's more explanation here. It's much better than that one. This is a noise point. It doesn't contain any. This is a much better picture. Please follow this one. This is a noise point. This is a boundary point because that point contains less than 4 points. But every red points contains 4 points. You can see that. If I center around the red point, it contains 4 points. So that is a dense point. So all the dense points together is called a cluster. Okay. So again, there's some explanation. Look at this one. This kind of pattern is very difficult to get in k-means, hierarchical clustering. To an extent, hierarchical clustering will help, but we don't want to combine these things together and so on. So if you look at density-based clusters, DBSCAN is the best. If you look at location-based clusters, k-means, hierarchical clustering, and other type of clustering can help. Okay, that's my conclusion. So if you look at this, actually the breast scan here, some of the malignant areas are there. These are all again image points, dense points, right? So obviously your DBSCAN can help. That is what the study mentioned. Okay, this is actually an interesting thing. This is the confusion matrix is actually given for some other study that's based on CNN that I'm going to talk to you. That is convolutional neural network. You can use neural networks also. There are different methods that they used and showed that it does a phenomenal job. But this is a very inexpensive procedure, very fast, very easy to apply, very easy to interpret, very easy to explain compared to the neural network that we will see. But sometimes performance is what matters. So fine, okay, you can use that as a way to address your needs. This is all fascinating. How does this connect to artificial? Oh yes, thank you very much for asking that question. Artificial intelligence uses machine learning method as their decision engine, and the machine learning method uses all these things as the methods to develop the decision tools for the artificial intelligence. Did I answer your question? Yeah, let's not lose track of what's our major goal. Major goal is really artificial intelligence, right? And applications. Answer. I suppose I answered this all. Okay. All right. So yeah, keep that question perspective. Look, we are in the artificial intelligence world. Why do we care about all algorithms? These algorithms and the data are the one that is feeding. It is the engine for the artificial intelligence tool, right? Remember, the artificial intelligence, is a combination of, again, many things, right? Artificial, I think, I'm not sure, you recall that, graph that I showed you, that artificial intelligence is a very broad category, right? And, that category is, this one. Here it is, right? Artificial intelligence includes machine learning. The machine learning includes deep learning. Deep learning is a subset of machine learning. Machine learning is a subset of artificial intelligence. So this algorithm here, there is a whole data that is overlapping this one, right? The whole data engine. Data engine, algorithm engine together is the decision engine for AI. Okay. And the AI is really the interactive implementation. Remember that. If I want to say it in 2 words, AI is, it's an interactive, human interactive decision support tool. Okay. So thanks a lot for that one. So let's go to the, so I kind of covered, cluster analysis now. Is there any question on cluster analysis or, dimensionality reduction? It's a good time to ask that question. Okay. So with that, I want to move to data and analytics for ethical AI. Okay. How are we doing? We're good. So this is one of the things also we want to talk about, right? Okay, we do all these things. How do we diagnose that we are doing a good job in terms of ethical AI? Because fundamentally, the AI has to serve the needs of humans, people, right? That's the reason why we spend a lot of time, and it has a potential. So how do we diagnose whether it's doing a good job? That is my topic, next topic. Okay. Ethical AI refers to the utilization of AI/ML for identification and solutions for equitable treatment of patients, specific to this application, patients. It includes providers, partners, and supporting management to accomplish the equitable health outcomes. Okay. Question. So do you think all these sources, methods like DBScan can be used to provide credible data sets? And can you simplify why DBScan beats all methods? So as I mentioned, I'll answer now this one. As I mentioned, there are many things. So there are many things about data. There are many things about algorithms. Okay. Yesterday I talked about only supervised algorithm. Now today I talked about so far unsupervised algorithm. Okay. All these things are part of our toolbox for the machine learning to do its job to provide decision-making power to the AI. Okay, so that is the, I would say that is the answer. One second, answer is open. Okay, no more questions. So so we need these things. Okay, I'm not expecting everybody to do everything here. It's not going to happen. It's tough, right? So that's why you will have a right team where you have a expert, domain expert, you have a data scientist, you have a data engineer, and analytics engineer also. Sometimes the analytics engineer will be a higher level of order in terms of automation compared to data scientists. Okay, so automation is also important, right? So how this, that's why nowadays it's called ML ops, AI ops operations. These are all coming into discussion because if you just do ML, it's not enough. It's about algorithms, right? Algorithm development. If you just do data science, it's not enough. It's about algorithms and data coming together. Okay, and data engineer, make sure that the data are provided in the right way, right format to the data scientists. Okay, so all these things have to come together for automation eventually. That's where the AI becomes a valuable solution. How do I say, why do I say that, oh, it's a 727, always active, always, untiring service to humans and so on. Why do I say that? Because it's automated. Nobody needs to follow through. You can go, once you implement the algorithm, you can go and sleep. It's okay. And then come back. What happened next day, you can see, through some monitoring of your dashboard, you can find out how it was performing and what are the complaints you're getting, all those things. But the thing is that automation, 724 around the globe, all languages spoken, irrespective of who that person is, all those things are possible only through AI. That part is AI. Automation, utilizing machine learning, algorithms and data. Okay. So I hope it's all clear. It's coming, hopefully it's coming to you. So do you think all these sources, okay, I answered that. Should DBScan only be used when providing data sets that have images or some type of visualization? So DBScan is when there is a density-based information you want to explain. Density means how densely the observations are together. Okay, so the disease states like the image analysis can be an issue of density-based explanation. That's why I brought in the DBScan. So if I conduct a research where most of the data that are qualitative, can I assume the DBScan? not the best application. Oh, that's a good point. If it is, you don't have to use one particular algorithm everywhere. So depending upon the data, you're going to use your algorithm, right? There are tons of algorithms, and I'm giving you some highlights here, these 3 days. And, for example, if it is a qualitative data, we can't use DBScan unless you are thinking about it as a multidimensional look. Dense points are there, where most of the dense points are there. So I would say, it becomes a, analytics problem rather than an image problem. The way you are saying it, it's still, you can use it for analytical purposes. So analytics is a wide scope, which includes all things there, whether it is discrete data, continuous data, image data, and all those things. So my suggestion is that, if it is a qualitative data, all of them are qualitative data. If you're still looking at high dimensional density based conclusions you need to make, even though it is not image data, you can still use, because it's about clustering, isn't it? DBScan is just about clustering. Remember that I kind of implicated it for specifically about image analysis, because in the image analysis also certain characteristics of the images can be an issue of dense expression in terms of the coloring, in terms of the grayscale of the images. Okay, that's why I kind of spent time there. It's useful, as I said, there are many things that are useful. We try to give you an overview here. So here I want to come back and complete this statement that how do we diagnose that the work you are doing is ethical or not. There is a way to do that. Okay. So what happens is that here is a good reference. I would say this reference, actually I got it today. Interestingly, he has addressed that one, and that is what I have. I have developed these reports. Basically, you will have to have a model description, model type, and date, and which state the data is applicable, right? So you are going to be very explicit about all those things. Not only that, for every feature, what is the probability of unethicality? That is, means incidence of the feature for the subpopulations. Okay, remember that. It's all about subpopulations. If you are not fair to a subpopulation, it is unethical. That is as simple as that. Okay, you are fair to your subpopulation, but not fair to another subpopulation, or not fair to a specific individual. These are all unethical issues. That is how it is defined here. It's a equitability. Okay, it's a equity and equitability, right? So equity, there is a difference I explained about equity versus equitable. Okay, equitable means everybody gets the same treatment, but equity means everybody gets the best of the same treatment applied to their situation. Okay, that is the difference between equity and equitable. And you have to create this kind of why certain features are more represented in certain subpopulation and less represented in subpopulation. That kind of discussion. On top of it, the model performance, and that's what he is saying here. Okay, on top of it, the model performance. Now, if you go to this here, he is talking about the precision, recall, ROC, AUC, confusion matrix measures, all those things, accuracy, all those things he is measuring basically, where these things differ according to the subpopulation. That will tell you the way to explain whether your model is applicable or not in that situation. So it is okay if you don't, your model doesn't do a good job for a particular subsegment, but it explicitly now through this report that you cannot use that. The model is usable for this subpopulation, but not this subpopulation. That explicit understanding and that explicit application is will help you to be more equitable to all. Okay. Any question on this one? This is a tough one, a little bit harder, because I see it for the first time. People, I'm bringing it, as well as I know not everybody talks about it. They will talk about what is equity and what is equitable, ethical AI, but not how to apply that. And I'm bringing you a way to apply. Okay, remember that. So there's a question here. So if we have different population ratios, can we adjust for the ratios? Okay, this is a very deeper question. Okay, that the way you asked it. With the given data, suppose I don't have enough sample from a subpopulation, there is nothing I can do about it. So I can't just adjust my model applicable to that. I need the sample representation, because what if that particular procedure works differently for a subpopulation. So I can't use whatever I get it on the model that I developed using a data which doesn't have enough representative sample for a subpopulation. I can't use that, okay? Because we don't know when we get the actual observation for the subpopulation, it will exactly behave like the other subpopulation or it will be different. So knowing this explicitly and implementing these decisions explicitly provides you, I'll come to that, provides you an opportunity to justify that you are doing an equitable job. Okay. The next question is maybe give more weights. Oh, what is meant by more weights? We don't know, right? You have to be very careful about that. See, we are not saying that, we are saying that no, we don't know how the treatment procedure will behave for the subpopulation. That is the main point. So by giving less weight or more weight, you cannot solve the problem. But addressing the fact that we did not do a good job, because I mean, it's not a problem of the developer. It's a problem that we don't have the right data. See, that's why NIH, surveys are all, you ought to be, I really, wonder how much effort goes into NIH, surveys. They spend a lot of time, okay? Got it, response with the additional ones is incorrect assumptions, okay. So they take a lot of pains to design right, to address the right subpopulations. For all the surveys they do a ton of surveys, and that's where the weights come into play. But weights alone will not solve the problem. You still have to have enough samples. Okay, so enough samples. This is where the statistician comes into play. Remember, I tell you, statisticians, they do a phenomenal job. We are not going to discount, right? But here is a great example. This is where the statistician come into play. They tell you, oh, you know what? The weights alone is not good. Weights are good substitute because you cannot get the whole population into your understanding, right? You need to have samples sometimes, sample-based work, and but you can additionally you need to use weights so that your representation is properly captured into your surveys, right? But then weights alone is not going to solve the problem what we are talking about, because if you apply the procedure for a particular population, if you have only few samples and with the high weights, that's not going to happen. Okay, few samples with high number of weights, it's not. So I can disregard the major population, focus only on the subpopulation as my data set. Understand that I'm analyzing only this subpopulation. See, it's a very tough practical practical issue, right? How do I conduct my research? We are talking about some more deeper into AI ethical issues. How do we conduct our research? It's a tough issue because it depends on which subpopulations you focus. But oftentimes you can't just sit there. Sometimes you want to do overall study. But be clear, be careful in understanding and explaining that I have done only these subpopulations. Then it makes sense. Okay, thank you very much. So this kind of report will help you. So stay put on that one, that this kind of report will help you. Okay, so all right. So we talked about this. Now take a look at this one. I certainly encourage you. I can put this one in the chat area also. He has done early studies in this topic. So here comes. Where is that one? The chat area. Go to the chat. Okay, here it is. So this is the link. Once in a while I put, here is the link, for example. All right. So I was talking about, how to show that a company has been doing its part for equitable AI. Exactly. I talked about the NIH surveys and so on and so forth. You have to combine and see whether subpopulations are well explained. Okay, which subpopulations are not well explained. That is what. And if it is not well explained, don't use it. Okay, that's a point. At least you should be explicitly making that case, in your group. Otherwise, it will become a national news. Believe me, and it happens all the time. Recently, I saw a study about how people are using the chest X-rays incorrectly for African Americans. Okay, so it will become a national news. It will become a publication. So be careful. Think about all those things. I don't see the link. Oh, I'm sorry. It went to It did not go to everybody. Here it is. Okay, so with that, I conclude about unsupervised algorithms. Okay, so we can take a break because I'm going to introduce next to the machine learning algorithm support vector machines and neural networks. We'll start with that one and then jump into introducing you Python programming platform, specifically Colab and Kaggle, and showcase one actual solution for fetal status prediction. Is this a good time, Tom, that we
Yeah,
can take it?
this is perfect. Let's go ahead and take a 10-minute break. Thank you, Dr. Samba, and we'll be back with everyone in 10 minutes.
And then I will have another 1 hour and 20 minutes, right?
Yes, sir. Absolutely.
Thank you. Thank you very much. All right. Welcome, everyone. Thank you very much. I want to introduce some very special machine learning methods which are not used by statisticians, okay, at all. Three of them I'm going to introduce you today. One is what is called the I already covered the random forest. Its extension is what is called the boosted random forest. Okay, XGBoost is the most powerful. The boosting is that random forest, it just does an averaging of trees. If we will build 2,500 trees or 5,000 trees, or little small trees. Okay, the premise is that if each tree has let's say 1% extra or 0.5% extra or 0.1% extra predictive power than random allocation, then if I combine thousands of trees, then it's going to beat any other algorithm. That is the idea, right? It's like a piranha, right? Piranha, small fish. How large number of small piranhas will consume a huge animal. Similar to that, right? It will beat large collection of small trees. Each tree is only small margin of better prediction compared to random allocation. And if you combine thousands of them, it will do a great job. That is the idea. So, what XGBoost did it, again, remember that, regularization. See, before XGBoost, initially random forest was there, and it was beating regular single decision tree, okay? And it is easier, and it was beating in some places the regular statistical model. But when random forest came in, they did not do it. They did not think about regularization, okay? And they did a boost, the boosting method. Boosting refers to basically take a shortcut to the optimization result. Okay, by that what I mean is, wherever the builder tree, first tree, wherever the misclassified observations are there, you give more weights to that so that the next tree will do a better job of those misclassified observations. Okay, so they do this kind of continually improved trees and then combine them. That is called boosting. But even then, that didn't do it. The complete job was not done. What is that complete job? Remember that I always said, whatever the model you do, whatever the algorithm, new algorithm you develop, method you develop, you need to still use regularization. What does regularization mean? Adjusting for the number of parameters. That is what a graduate student did. He didn't even get a PhD. The XGBoost guy, the student, he was just a graduate student. He did that adjustment for the number of parameters. Suddenly, XGBoost was winning all the competitions. Initially, random forest was winning, and this one now XGBoost was beating even the random forest, and lots of competition. XGBoost. Even now, XGBoost is doing a phenomenal job. Okay, all because he used regularization. Everybody did the boosting, everybody did the random forest, but he is the first one to do the regularization. That means addressing for the number of parameters. Okay, so it's not overfitting. More number of parameters means more number. It's overfitting, right? And once you adjust for the parameters, you're kind of controlling that overfitting. So that is about the trees, random forest, boosting, and XGBoost. Okay, that's one broad color. broad collection of models that people use in AI. Okay, the other model is what I call it as what is called the the support vector machines. So take a look at
Doctor,
this. Yes.
we can't share. I don't know if you're trying to
Oh,
share your screen. We can't see
not
your.
share. 1 second. I'm sorry about that. Wait. Okay, let me share again. Okay, please let me know. Are you able to see?
All right, we can see. Looks like you're starting to share. There we go. Perfect.
Okay, thank you. So support vector machine is a very fascinating application developed by a Russian. For 30 years they have been doing it in Russia, and finally, when somebody used that for image identification, it won in a competition. Suddenly, it got popped, right? Very fascinating. I'll tell you what's going on. So here there are a collection of one class of observation. This is another class of observation, right? Two classes are there. The problem is, how do we separate these two classes of observation? That is the fundamental problem. Identification is a classification, right? So classification. So how to classify these two observations? Oh, well, just put a line here, right? That's a line here. That separates out. In this very simple case, what if the observations are overlapping and so on? So some of the orange points are here, some of the blue points are here. Those are all adjustments we can make. Mathematics, subsequent advanced mathematics takes care of it. But the point is, the simplest case is that, as long as you find this line, you are good. You have solved the problem. And the very interesting point is that this line, okay, is the same line whether I have billions of blue points and billions of red points are here, isn't it? It just depends only on these 5 points. 1, 2, 3, 4, 5. These are called support vector points. Okay, this line of separation depends only on that. It doesn't matter if there are billions of points are there, left side, right side, doesn't matter. Now, that's the beauty and the simplicity of this one, right? And also, always the separation is a straight line. In a higher dimension, it's called plane, flat plane. It's not plane, right? It's not. It's same P-L-A-N-E. Okay, it's a very thin sheet, right? In a higher dimension, it's always a this flat line or a flat sheet. However, still it will do a great job. Isn't it funny? It is interesting, right? There's a beauty here. There's a mathematical ingenuity here. So anyway, so this is already extended with the whether the points are points are overlapping. There are some cost adjustment method they introduce and take care of it. And of course, this method should also use. Somebody wants to say the answer, a keyword, as with any other great method. Use regularization. They have developed that also. But the question then is, okay, will it distinguish this one, separate this one? This is not a separation on one side versus another side. This is one inside another. What do you mean by line or a sheet of paper or plane can separate this out, right? So the mathematics says, well, you can do a this is why it is called this is the observation space. You convert that into the feature space. Okay, this is the feature space. Okay, this feature space, you can elevate the blue observations, red observations to a higher level, and depress the blue observation in a third dimension. And at that in that transformed data, that is called feature transformation, feature transformed data. There is a mathematics for that does it. We don't have to worry about it. Then in that space, this plane sheet will separate out these red points and blue points. Again, it's only sheet. It's a plain sheet. It's the straight line type. Okay, you don't have to do the curvy, separations and so on. Okay, yeah, statistician would do that. That's a different thing. But even then, statistician will not do this kind of problems. Cannot solve that, right? As it is in the observation space, you cannot solve that. In the feature space, you can solve that. Okay, that's mathematics behind it. Oh, what about this one? Can you do that? It's a circular data points here, mixed, in this way. Okay, so you can't put a line here, right? Isn't it? But there is a transformation space, the feature space. Within that, you can have data transformed in this way, and a line will separate this. A line will separate this red points versus Good points. So they figured out all these things, so you don't have to worry about it. I'll put another one more example. Again, this is very curvilinear, right? Same thing, use transformations from the input space to, which is an observation space, into the feature space. And within the feature space, the red and blue are separated out, by a sheet, by a plane. Okay, that is what it says. And all kinds of complicated problems you can solve it, okay, with the support vector machine. Even though it looks like very simple method, it's all about line and a sheet of the planes, right? All kinds of problems you can solve. Here are some examples that you can pick up. So even here you can see this kind of very curved parts and all. You can do that. Circular parts I showed you can do it, and so on. Now comes the neural network. Okay, so we are good. My point is now another 5-10 minutes. 10 minutes I'll finish this one, and then we can go into learning Python and then applying it also. Okay, all right. So computer science people thought that there must be a way to replicate how the humans think and then make it into a machine, right? So the brain cells, neurons, we have almost, I don't know, billions of neurons, if not very hesitantly, I want to say trillions, but then just keep it as billions. Okay, so that every brain neuron cell is connected to other neurons. Okay, that's why it's a network of neurons. Okay, and can we replicate that behavior into a mathematical construct? That is the question that is being answered here. So the input comes into it, and then whatever the input is really the thought input, right? But then a thought triggers a certain neuron in your brain. A thought triggers certain neuron in your brain. Okay. Okay, this is so interesting. I'm curious. I'm trying to understand your question better. Are you? Am I hearing you that you are not able to connect to healthcare and health disparities? Is that a question? I'm curious as to how. I have been talking about it constantly, the same thing. I'm at times when I go into deep, it looks like I'm only talking about the topic, but it's always connected to your algorithms and data, which is feeding you to the AI machine, and that algorithm and data are coming from healthcare examples. And the one example I'm going to show with Python and so on, it's going to be healthcare. And I have showed you yesterday. I showed you a lot of healthcare examples. Today also I showed you some healthcare example. So I'm not clear what is your concern here. Okay, as in the applications are included. Oh, okay. So as in the case of the SVM, okay, all right. Thank you very much. So so what happens is that again you can take the image cases, right? So the image is can be again dense places will be happening all around in that image. Let's consider that way. Same thing like what we are talking about earlier about the breast cancer, right? Dense cases are if you look at the dense cases, most likely it can. I'm saying most likely it's about dense in one place and then spread out thinly, right? So if how are we going to separate out using SVM? It's one possibility, right? There are many algorithms that we talk about, and we need to know. Sometimes we may not know which one to use. So what you do, you use multiple algorithms and then find out which algorithm performs well, right? So in that case, for example, even here, which is a simplified case is this, right? This is the dense part. This is the dense part, let us say. This is not a dense part. So you need to identify this dense part, right, in the algorithm. So what we are saying is that there is a transformation called radial basis function. If you apply radial basis function to transform this data, input data, the image data into a feature space data, then you can use SVM, the separator, SVM separator, the plane type separator to distinguish where most of the dense parts are in the image. Does that sound to you good? It's the same thing, we will end up oftentimes we will end up using multiple methods to separate out. That is one of them. Okay, so again, I'm trying to give you an overview of methods and methodologies and algorithms and so on. But when I talk to you and explain, it looks like I'm going deep into it. It's only to explain that part, and then once I come out of it, I'm talking about other things. Remember that. That's how I try to bring out. But thank you very much for catching on that. It's a good idea to keep reviving our concentration that oh, it's all about really the applications and so on. Okay, and you are going to learn throughout this month. Many people will be talking about these things. Because there are many days. These things are going to be repeated and explained, applied. In terms of actual data. So you will have a lot more chances. Today is the first. Yesterday was the first day. Today is the second day. Tomorrow is the third day with me. And it is just an overview to get you hopefully excited about the possibilities, and then we will take more and more. You will take more and more. You'll be able to absorb more and more, and you will be able to connect also all these things from higher level. So that's my hopefully that's my purpose with this fulfilled in these presentations. Okay, thank you very much for holding on this some of this explanation. It's very important. Appreciate that. Okay, excellent. Okay, so what happens is that when a thought comes, it fires a neuron in your brain, and the brain has different components, right? But a neuron, depending upon whether it is an mobility, depending upon whether it is a visual, depending upon whether you are hearing, depending upon your own thought process, logical process, or going deeper into deep levels of thought process, that is somewhere in the brain. A neuron fires. Okay, and possibly sometimes it's not just one neuron, multiple neurons based on multiple inputs. Multiple neurons will fire the signal, and it will fire the signal to reach connected network of neurons, and based on that, eventually there's an internal calculation going on. This is the idea, right? Internal calculation going on, and the frontal part of our lobe gets the decision, yes or no. Am I going to go this left or right? Am I going to decide forward or not? That is the model that we are trying to replicate here in the computation. Again, now I'm only talking to you about the neural computation, which is resembling the human brain computation. Okay, that's the idea. So the inputs are coming here. I mean, again, I teach neural network probably for 4 or 5 hours before I probably not 3 to 4 hours I will teach before I actually talk about discuss working on solutions for the students in a graduate program. But I'm trying to give you the overview here. Okay, so here let's say there are 3 inputs are coming: x0, x1, x2 here, right? 3 inputs are coming. Interesting thing is, again, I want to simplify here. It's no big deal at all here. Remember, we take all the input, we give certain weight to each of these inputs. That's what we do. For example, if you are going to, in your house, you are discussing at home whom to vote, whether GOP or Dems, right? Then, your spouse says something, your parents say something, your children say something, right? It's just a fair discussion in that everybody gives an input. You take input and then you give some weights to it. Based on historical valuation of weights you have your own in your brain, you give some inputs to that. Giving weights to data is a fundamental process of calculation, and that's what we bring in here, right? So W0, W1, W2 are the weights. Okay, you are giving the weights, and then based on the weights, some trigger is happening in your thought. Okay, you know what? I see, my son has been doing a good job so far recommending about political, decisions. My wife is not interested. My parents, they are old, they are thinking differently. So I kind of, brain is making this kind of decisions. And then what we do, according to the mathematics here, the scientists thought about it and then, applied it here, is that, okay, we take all the inputs, and then we add some coefficient to that. That's a common average coefficient coming from historical weights and so on. That's B. Now, this is sent through, some kind of a decision-making, function that is called, the activation function. Okay, it could be a logistic function. You know what is a logistic function? It outputs values between 0 and 1. So from that collection of input, the cell, after going through the weighted sum process, it's very simple. Excel calculation, product sum calculation. That's called some product or product sum. I think it's some product, and then transform it using a logistic function, and then it tells you 0 or 1. Okay, because it's a value is between 0 and 1. It may be more closer to 1. It may be more closer to 0. That is what is happening there. But it's not one cell that is making it, right? There could be lots of input, lots of cells are coming into play, right? So here you have a lot of different variable inputs from a lot of different people, and then this is the output you are going to make. You are going to connect these inputs to the outputs. But there is some internal process that goes on. So these are called hidden internal layers. Hidden layers. This is called the input neurons. These are hidden layer neurons, and this is the output neurons. Okay. In this network, just to explain, in this network, there are 3 input neurons, and then 4 first layer hidden neurons, another 4 second layer hidden neurons, and then 2 output neurons. Okay, it could be 1 output also, 0 or 1, but let's say it is 0, this 1. Okay, 2 output neurons. I think it is better said as 1 and 2. So this could be a different problem in this case. 3-class problem. No, 2-class. 3-class problem. 2-class problem is done into 1 neuron. 3-class problem could be with the 2 neurons, because whatever is not decided, undecided could be the third one, not decided by these 2. The main point here is that this is the structure, and then this data is start coming here, and every cell does same computation. What is that same computation? Excel computation. Brain is doing Excel computation. What is that? Some product of the weights going through the activation function. Right now, we just talked about only one activation function, that is logistic function. But there are many other activation functions also. Of late, ReLU is becoming very popular, So that takes only, it converts the continuous value either, always keeps it 0 if it is negative. Otherwise, it gives you whatever its positive value is. That is called ReLU. Okay. So those computations are always, this computation is done this way. Weighted average, all these things, inputs are going into this one, this cell, weighted average, the activation function value, weighted average, activation function value, weighted average, activation function value, weighted average, activation function value. These weights are starting weights, but that doesn't have to be the final converging weight. So it goes here in this way. That is called feed forward. It goes from here to this here, and then from here to this final output. But we are only talking about the supervised algorithm. That means we know the outcome values here. That means we know the outcome values. So whatever the outcome value we get from here network, there will be an error there. If there is no error, then it's converged, right? There would be oftentimes there will be an error, especially in a computational neural network. There will be an error. So you back propagate the error to adjust the weights. Okay, so you do the back propagation. The computation steps are done to do the back propagation. In the back propagation, we are basically adjusting the weights, so that what will happen when I come back to the second time the feed forward, the errors will be reduced, right? That is the idea. Okay, and then it will keep on reducing until some threshold value. You are satisfied. Okay, you stop the network from training. Again, you have to use the regularization, all those things. Those principles are constant. Okay, the point is we use what is called the feed forward and back propagation method. In terms of every cell, it is just the same computation. Some product, activation function, output. Some product, activation function, output. Some product, activation function, output. And then boom, back propagate the errors. Feed forward again, back propagate the errors. Feed forward again, back propagate the errors until the errors and the weights point out to very, very low errors compared to the outcome values. Your network is done. That is what we do. And what here in the picture shows is that this has a lot more weight. So we can visually see this one, okay, where the more weights are. So it says input 1 neuron, input neuron 1 has a lot more weights to the output neuron 1. That's what it says. On the other hand, 3 doesn't have any value, much value, to this output. But this 2, the second neuron here, has high value to the second output neuron. This is a kind of interpretation for the neurons there. Okay, so could you help make the slides in full screen mode? Oh, okay. Yes, I think. I can do that. 1 second. So that is what happened. But the problem was, they were doing this 30 years back. I told you that. I have seen is when I was a graduate student, I have seen the neural networks, and in at least one case study I saw, it won the farmers interest to classify the apples, right? But it was not stable. It was not doing a phenomenal job like as currently it does. There are two things why it happened, why nowadays it's more reliable, more stable neural networks, and why it is more popular also, and it is widely applicable, is that two things happen. One is they did not know back propagation at that time, as well as now how they know it. Okay, so that's one thing. Of course, the second one is a lot of data we can get nowadays compared to the olden days. So those two things have helped the neural network to be more successful and more applicable to more variety of problems. Okay, a high number of problems. I'm sorry, sometimes I do this because it doesn't move. So where does the deep learning come into play, right? So if initially I was putting some other thinking like this, I just thought it's fun, you'll see. The brain works the same to all, right? So the point is deep learning came into existence again because we have enormous amount of data. We can go deeper and deeper to solve all kinds of problems. You need more and more data, whether I don't know whether it's considered as a blessing or a curse, but then we need more and more data to do bigger and bigger problems to solve. Image recognition became a possibility with the more and more data. Okay, all kinds of, as I said yesterday, there is 175 billion parameters of are used in BERT, the GPT-3 model, language model, GPT-3 model. 175 billion parameters. If you are using 175 billion parameters, you need at least 175 parameters. It should be many orders of magnitude, that many number of observations we need. Okay, so that is possible only because we have that much data, and the performance of the deep learning, is more and more is achievable, and it's happening today because of the amount of data. That's why data became the oil, and everybody got excited about, oh, data is the new currency, right? It is new currency. Why, Google is valued $1 trillion? It's because of data, and they know how to leverage data. Okay, your surfing data and my surfing data, and place the right ad at the right time. Phenomenally accurate. Of course, they don't just put one ad. They give opportunity to this is the business issue, right? They give the opportunity to the sellers, the market people, compete for the ad. So you are going to get multiple ads, but in the same class of requirements it comes up, right? Because they also contribute to the goodness of the performance of the model. So the point is, data is the new resource, phenomenally powerful resource, and it is makes possible the deep learning more and more. Because deep learning simply means you are going to get not just 2 layers that I showed you in the example, but many layers of cranking the, juicing out the data and juicing out the information, weights from the data. Okay, it comes down to every feature in I'm talking about an image here, right? Coming out to every feature, and we talked about the feature can be not just about the cause, but also the cancer image I was talking about, right? Breast cancer image, or we will see pneumonia image later on. That is tomorrow. I'm going to do a image analysis, deep image analysis. Deep learning is coming tomorrow, in terms of the case studies. But today I'm introducing that as part of the neural network. Okay, so we are good in terms of time, so no concern. So the point is, this is what it is. We take an image here, as an example. It's a very classic example, classifying 10 digits into, correctly based on the images. The neural network identifies it. Oh, this is 2, this is 6, this is 8, and so on. And nowadays it is about very close to 99.4% or something like that accuracy. Okay, the machines can achieve. So what happens is that again, this is the density of the pixels. Remember, it's a pixels is basically 3 levels. If it is a color, if it is a black and white, it's only one array of numbers, between 0 and 255. So this is really a number between 0 and 255. And if you know how to analyze the numbers, you can solve the problem. But then you don't know, how do we instruct the machine that this is really 2, right? So it goes through, it goes through kind of collection of cells here, like collection of the SR node type information, right? Or the numbers, in this case 0 to 255, right? So here it's all 0. It's all 0. So they will have you will have a kind of the running collection of cells that computes the total value. For example, it's very simple. Total counts within that area. Let's say 4 cells at a time. It's scanning through the page, scanning through the image. Okay, 4 cells. It could be 6 cells. That's what it means here. Okay, N1 channels. This is a 24 by 24. Okay, 24 by 24. It takes. It's 28. Okay, but 24 cells it is computing the numbers in that 0 to 255. So it's just adding that, right? Will give you the density. But then it's not in one layer you're going to do that. You're going to do that to summation, and then you are going to find out it's something it's called convolution first, and then max pool. You find out the maximum amount that is coming out of this 24 by 24. What is the maximum amount? Okay. So as you scan that, right? Remember that, and that is what is happening here. And then you again redo this value by 12 by 12. You keep reducing it. Okay. And then finally you come to 4 by 4. From there, you flatten the information. Whatever you flatten all this information into one big vector. Just this big vector is what is called the multi-layer perceptron. So in the case of here, this is called multi-layer perceptron. Okay, it's the input layer, hidden layer, and output layer. So you can have multiple layers here in one neural network. Just one finally connecting to the output is called a multi-layer perceptron. So this is what the flattened values are in this picture. Okay, so you finally come to the multi-layer perceptron, because once it comes to the multi-layer perceptron, you can do your feed forward and back propagation to solve the problem. Until then, you are kind of trying to summarize the data in such a way, figuring out where the maximum signals are. Okay, so in this flattened size, you will find out 2 will have maximum signal here, here, and here, and 1 will have here and here and here, things like that. So that variation is what is giving us the solution as to how to identify that it is true. And that is same. The method is same even in the pictures, other pictures also. Same thing, where the maximum signals are. The maximum signals are attained by running through this kind of regions, scanning through that picture and finding out the numbers which are coming from the RGB. If it's a color, if it is single color, black and white is just one layer, what is called the one array of numbers. And these numbers are between 0 and 255. That's a connection. How the images are converted to numbers are converted into the maximum signal areas, and the collection of maximum signal areas points out whether it's a 2 or 3 or 1 or up to any number, right? Up to 0. There's a question here quickly. Just let me take that. Interesting URLs to play with neural networks visuals. Okay, sure. Thank you. Wonderful. So actually, whatever I have explained, it's in the next slide. Okay. So basically, this is what I said. No, you are scanning through this, going through this like this. Okay. And this is called the padded area, because sometimes the output area may not be exactly divisible by this kind of 3 by 3, right? So you have padded area at the end in the corners, the last one on the front one on top and below. So you do that, and that's where you got this maximum signal. So you see this one, maximum signal, and then there is also called the features also called kernels. The kernels are features here. So you kind of try different kinds of features And that features tells you that you apply the features here. See, this is just a simple feature. I said, but the feature is summed up, right? That is one feature. But this is another feature here. We are using that feature here. Once you use that feature, you get 308. That's how you got 308 in this one. Okay. And then you use second feature for the same second feature. You use you get a minus 498 third feature, and then you sum it. So there are different ways of computing these signals. And what I told you in the beginning is the simplest one. Just sum them and then see where the signals are. Okay, that's the easiest one. But complex pictures requires complex features, and people have done quite a bit of work on how to automate the designing of the features to make sure that you get the signal that you want. Thank you very much on that reference. So the same thing is happening for text. Same structure. It's a network input. Some product. Logistic function or ReLU. Some product, logistic function ReLU, some product, logistic function ReLU, and then backpropagate the errors, repeat this one. So I'm going to give you very important terminologies now on this deep learning network, in general networks and deep learning networks also. So you want to do certain strategies in terms of computations for various reasons. You want to take, suppose you have 10,000 observations, you want to batch them, okay, in such a way that it's usually batch it in such a way that it's divisible by the number that you have, like 100, 50, things like that. You batch them. Typically, it will be orders of 2 power some number, okay, 16, 32, 64, and so on. So you run through this network by batches. That is one thing. So you remember that. I'm going to use that word batch later. Okay, batch size. I will use it. I also told you the error propagation, back propagation. I also mentioned about how much error you have to tolerate, to say that you have completed the network. That is, we are talking about error level to achieve. I'm going to also introduce. I have introduced you loss function. You remember that terminology, loss function? Same thing here. Loss function could be as simple as the difference between the input and the output value calculated from the network versus the outcome value, right? In the end, as simple as the difference, but it could be something more complex also. It depends on the outcome value you have. So loss function is for classification, the loss function is typically what is used is it was used by the statisticians also before. Okay, so what they use, the log likelihood, is actually considered as the entropy. Okay, sum of the entropies. And because maximum likelihood estimate actually comes out to be sum of the entropy values. So it is the same thing, but it's a loss function. So we also use the same loss function here too for classification. Okay, you can use the summa squares here, mean square error here for the continuous variable. But more often, you will see that people use more often people design it as classification problem, whatever they do, usually. And you can do that, okay? Even continuous variable, you can convert it into classification problem, by designing the outcome values between this and this is, one, let's say, if it's income, outcome value is income, 0 to, let's say, $5,000 is 1, $5,000 to $10,000 is value 2. So now you classify that and, consider it as a classification problem. By the way, this is a slight comment I'm going to make. Classification, the classification problems are much easier to solve compared to continuous variables, because remember, continuous variables can, even one observation can become an influential observation that will throw off, the analysis, unless you do a good job about influential observation, right? In the statistical learning. So, there is generally a, worry about doing correctly in the way the statisticians did it, right? I am probably loading my statements here, but just for fun, I said, right? And compare these methods. So the point here is that most of the problems can be converted, and people do it as a classification problem, and they're very successful also. So loss function, you have something called the step size, okay? So which is also called learning rate, okay? They used to call, a statistician used to call step size, and now they are called learning rate. The learning rate has to be very, 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 very small, because there could be small densities that might that you might lose track of. If you have a high, large learning rates, okay, you might lose track of that. And remember this, the image, for example, image analysis are all, small dense areas are going to differentiate, the disease case versus non-disease case. Okay, so it is important to try with the lower and lower learning rate. So I hope you are noting down these things. I'm going to recall all these things when I do neural networks. Okay, the learning rate, the batch size, and batch size, learning rate, and then the when do we stop, right? The stopping rule, right? When to stop the neural network. So these are common things that I will use when we solve the problem with neural network. Okay, so we're good. And with that, so when we build a model, this is what you will see also. In a large model, it will tell you, what is the dense layer. Dense layer is the in between the one, right? We have input. This is the hidden layer, dense layer. So here we are talking about, it will tell you how many parameters that particular model that you are designing to be. In this case, there is 39 million parameters, right? Statistician won't even think about this kind of issues. Why? 39 million? I don't want to work. We don't know how to work on some, but we figured out through machine learning how to work. Okay. Now, there is something I'm going to skip, what is called how to explain and predict, because this is something, it will take time, another 50 minutes. I don't want to spend there, unless one possibility is here, I will spend here, but then I will do the case. I will do the Python programming now, okay, and extend my time. One option is there, okay, do the Python program. They do this one interpretation of the seemingly looking black box models. How do we interpret it in healthcare? Okay, and I'll give you some examples. It may delay something beyond 1 o'clock, Tom. Okay, I don't mind spending extra 10, 15, 20 minutes maximum. Okay, that's one possibility. Otherwise, I can take the fetal classification problem tomorrow, because I'm just concerned. If I do this, if I do the interpretation, spend time in the interpretation, I may have to go until probably 1:15. Okay. Otherwise, I can cut this out. I will anyway. It is there in part of your notes. I will distribute, and then finish it at 1 o'clock. You can make the call. It's something that you can post it in the answer. Okay, in the chat area. I'm fine with that. So let me skip for now this one, interpretation. I'm going to go with the introducing you to Python. How does that sound?
I think that sounds great.
Excellent. Okay, so we'll skip this one. Let's move on to Python. That's wonderful. Thank you very much. So here is a very important strategy tool I'm going to introduce you to. Okay, that tool is use Google Colab. If you have, every one of you, if you have Google account, you can simply sign into Google account. Okay, and then ask for this one. Okay, colab.research.google.com. You will be getting the ability to run Colab, which is basically the Jupyter notebook. This is called Jupyter notebook. Okay, 1 second. Why is that? It's not coming fully. Okay. This is called Jupyter notebook. So why don't you just jump in, everybody? You can do this. Just sign into your Google account. This is my Google account, nsm001@gmail.com. Once I sign in, I just go call into colab and research.google.com. I get this notebook which is basically a Jupyter Python notebook, and the Python, I will show you what this Python version is and so on. And I'm ready to do Python. But that's not the question. I'm going to teach you now what is Python, how do we learn, how do we start, then start, learning a little bit today. And within half an hour, I will transition to this one, this fetal health analysis, where we are using this Python 3 environment, okay, from Kaggle. Okay, stay put. I'm going between two systems here. And that is my recommendation to you. Okay, just use these two. Just use these two. You don't have to do Anaconda, all kinds of things, because you have to update these packages constantly so that they're all syncing properly. And that's a tough job. And believe me, I have been doing this for 7 years. It is a difficult job to make sure that we can keep all these packages, because there are tons of different packages that you have to use in your work. And these packages may not sync well. There are so many reasons why it may not sync well. And the benefit of working with Kaggle and Google, is that Google makes sure that whatever they provide as a platform, it has integrity. That means it will work. It's a huge company, right? It's a image issue. It's a credibility issue. In the same way, Kaggle is another platform I will be using. Kaggle is another platform I will be using where you have all kinds of data science related projects there. And if you just go there, kaggle.com, again, you have to register your name. Please do register. If you haven't done it, do it now. Just search health. I did that before. You will see tons of projects. You don't need a course beyond this. You have tons of projects for which experts have given solutions. One in this platform. This is a competition platform, data science competition platform. Tons of projects are there. Look at this. How many of them? So healthcare problem, prediction stroke patients, understanding papers with text analytics, fetal health classification, Parkinson's disease, health insurance, machine learning for mental health. Same thing. Sometimes it might come. Mental health tech survey, Heritage Health Prize. They don't have it now. This was the first prize they announced, years back, 9 years back, and how this competition became very popular. And there are a lot of people now. Companies are posting, competition nowadays. I'll show you momentarily. Okay, and health analytics, diabetes health indicators, all kinds of things. Student mental health, Ghana health facilities, data for mental. So my point is, you have tons of examples here. These are the only 2 things you need. I am actually deviating from my practices from in the last 1 week. And I'm committing myself today, starting from today, only these 2 I'm going to use it, because it's a lot of pain. Otherwise, using other platforms. And if you go to Stack Exchange, Stack Overflow, and look for solutions because you are not getting some solutions, what are the solutions they will give? Maybe more, older solution. And you may think that, this is 2,000 people like it. Most likely it's a very old problem. So that is working. Unless it's a very foundational issue, it's okay. But if it is a very specific data science related question about the algorithms, how the formulas work, this and that, in specific some data structures, that may be a old solution. It may not work with a new platform. So I'm making a commitment to you and asking you to do the same thing. That just use these 2. That's all you need. And I'm going to prove it, right? For example, this one, it just told me because I subscribed, a few days back. I ended up subscribing for Colab Pro. They have different versions, but you don't need Colab Pro. You can work with the Colab, okay? Colab Pro, I needed it because I was verifying some solution, huge amount of data. So it was expecting to give more resources, so I ended up, subscribing for it for $9 or $10 per month. For me, it's okay, because I need to show value to people around me, right? The point is, I can go and open new open notebook, right? And let me just open notebook, and I was just checking Python and pandas for data science productivity, control flow, data structures. These are all just, I was verifying this thing. Strings, how to define, work with strings, read SAS format files, okay, in Python, right? So I want to show you, this is the one I was doing, and it was asking me to do more, allocate more resources. So I could not allocate more resources with the very basics, basic membership, that is Colab member. But then Colab member, every Google account will get it. But Colab Pro, you have to pay a little bit. Now, see, this is how they make money, right? It's called freemium. Initially, they'll give free, and then they say those who need will pay for it, and that's what happens. So these are actually my notebooks. I'm calling it from my Google Drive. So I use Google Drive to store my programs. I can bring it here, do work my programs, and then send it to people, whatever it is, And also I can go to Kaggle, move this program to Google, Colab Pro, and work in my system rather than working with Kaggle. Here is another secret. Kaggle itself gives your compute power. Okay, it gives you 30 plus hours of GPU. Very expensive, actually. It's amazing that they are giving that much resources to us. Okay, so I can actually run this, copy and edit if I go there, and I will come to that. But because before that, I want to teach you a little bit of Python. Here it is. It is coming out as still working on, right? Coming out as a Jupyter notebook. Again, see, look at this one. Same thing. Now it's a Jupyter notebook. I can run it. Here is what I was telling you as a schedule data save version. I don't want to run. Well, we can. I'm not interested in running right now, but let me show you here. You see this one trigger? No, I don't want to trigger that. I want to show you there is a GPU available for me, right? So, okay, settings. Okay, here it is, accelerator. So I can use TPU. TPU is the Google chip. GPU is the, generally comes from NVIDIA, okay, chip. So I select, they say, oh, you got 37 hours, you already used 27 hours, okay? Just warning me, that's all, okay? But the point is, I get 37 hours every week. You don't do that much work, right? Look at this one, isn't it? It's every week I will get 30 plus hours, sometimes say 30 hours. I think it depends on the combination of TPU and GPU usage. Okay, GPU is 37 hours, TPU if you use it's more expensive and more powerful also. Okay, I don't need that. My point is, what have I done in an exciting way so far? Talked with you exciting way so far. I'm making very important conclusion here. For learning Python and using Python-based solutions, either in Google Colab or in Kaggle, you have enough resources to do your work, to learn, apply data science related projects, both in terms of the resources and in terms of the case studies, codes, examples, best practices. So your question will be, oh, so I don't need an Anaconda. No, I have Anaconda too, but I'm going to avoid that going forward. I'm sorry, Anaconda, that's a fact, because I got trouble updating. I don't know which package to update this. I will solve a problem 1 month back, and then I come here with Anaconda, it won't work. It has happened to me many times. And then I have to spend time updating the packages, this and that. It happened today with R. R Studio is the one. I'm not bashing here. I am just sharing my difficulties with you so that you can make good decision. And I have already made a good decision. So I ask you to check it out and tell me or communicate with our community whether this is working for you or not, because I want to hear your difficulties with this plan, with this idea. Okay, it's very important. I feel how we can quickly move on with our needs. Okay, hi. Since R is heavily used in health research, is there any chance of having a demo for heavily R users? Not today. Okay, I teach statistical learning and also neural networks. I teach with R, but not today. Okay, I am actually transitioning more and more towards Python. I realize that I have to do, because the advanced AI is possible with Python. It takes, for R, it takes time to catch up with Python, the development that Python does. Unfortunately, these are true. Maybe I'm taking very strong position. You might think that way, but I have to tell you that no, my troubles have been pretty bad, so I'm making decisions now. Yes. Okay. I hope I answered those questions. So let me go in and teach you a little bit of Python for you, so that you feel comfortable in some of these codes. Okay, it's very easy, right? Oh, okay. Read the data here. pd.read CSV, and this is the storing point where the data is already there. You can download the data. Go to that. That's another thing. The Kaggle provides the data, codes, and the best practices discussions. Okay, so I actually downloaded that code, not this code, but the other deep learning codes. I ran it. I ran here as well as in Colab. That's why I ended up paying for Colab Pro. And because I wanted to check it out, how things are all working and so on, so that I can share that experience with you. But here, what PD means now, so PD read underscore CSV is a way, it's a function that is available under what is called pandas. But pandas is given an alias called PD. That's what it says here. See, import pandas as PD. So the whole pandas functionality, can you believe that? Pandas has 3,743 pages of guidance notes on how to use pandas. Pandas is all good enough for you for most of the applications, and they are improving it constantly. It's good enough for you to do most of your applications, okay? At least in this application, only pandas. Okay? You can see that in this application, it's pandas. And there is also sklearn. That is another, all algorithms are available in sklearn. Okay, that's a package, and it is so big. Sometimes you want to only select some very specific things. Oh, I want train test split from model selection, collection of functions from this package sklearn. That's what this is. Because it's so big, you don't want to import the whole thing. Okay, and you might also wonder, okay, what is this? He is only saying train test split. Where is validation? Here is the practice issues. What I told you is the gold standard. That's what I expect people to use. Okay, but sometimes people just use, okay, training and testing is good enough, because they are not going and talking about the real world, and so they're just doing it in a hurry, just testing out some ideas and so on. So you can do it that. Okay, so these are all some practical issues why people do what they do. Okay, so I'm going to introduce you few more, Python here. Okay, so let me go to. I'm going to now I'm Kaggle. I'm going to go back to Colab, which is my platform for Python, right? By the way, yeah, you don't have R facility in Colab as far as it's not. Okay, so I'm going to open a notebook, which is my notebook, okay, which I already opened it. Let's say this is okay. I did include about Jupyter, introducing Jupyter. So I start from very basic things. Oh, how do you download Anaconda, Jupyter, all those things. I did that. I'm going to skip that now. Okay. So here there are some 15 lectures I have. I don't mind teaching separately 4 or 5 hours separately on Python. But today I'm going to introduce only 30 minutes of quick introduction so that we can read through, understand the Kaggle solution for fetal classification. So let me go to that. This is what it is, right? Installing Anaconda, right? Introducing Jupyter. That's what this means. I'm going to, I will introduce Jupyter here nonetheless, okay? But here it is there. So from the point of introducing Jupyter, I'm going to, well, it will take time. So let me just go into only the Python and introduce you this so that you will know to be comfortable around this, okay? So lecture 0 is the introduction to Anaconda Python, and 1 is about strings, okay? And the other one is about data structures, okay? Let me see whether the data structure is here. External local files, repeat data structures. I was quickly checking all those things. Okay, you know what? I'm going to check here. Yeah. Data structure. Okay. Okay, data structures and group. Let me start there. Okay. So my Google Drive, whatever I stored there is brought in here. Okay. So data structure is, let me go to the another one, locate in Drive. I'm going to locate in my drive. This is my drive, aim ahead, collections. This has very limited information. So a couple of examples about looping the data, right? Okay, this is what I want, data structures. Let's see. Okay. So this is what I'm going to open it, and it is coming to Colab. Very simple. Okay. So this is what I had it in my notebook, in my laptop Python, right? Anaconda Python. But here it is, I want to check what kind of Python it has, the Colab has, right? So before that, I'm running this command, which simply says, see, Jupyter is constructed cell by cell execution. and every cell can only print one, type of output. But I want to, sometimes, I'm an analyst, I go crazy, I put multiple commands in cell and then ask for output just to think about it, right? Look into it. So if you want multiple outputs, then you have to execute this. So you just copy and paste it and you execute it, right? Some questions here. How to get access to those files in Google Drive. Okay. I will post this. I have 10 lectures, I'll post it, but my point is today I'm introducing you with a couple of files. I can teach Python. It is better that I post those files. I have to teach Python fully, but 10 files are there or something like that. 10, 13 files are there. That is point one. Second one is you can actually, once you go here and go into Colab, whatever you do, you can save it as your file in your directory. So I am answering in your G drive. Okay, so I'm answering because I wasn't sure what the question is about. Is it about my file or you want your files? So you can save it, your Jupyter notebook, and then come back, call back and work again, save it, and so on. You can do that. If you want my files, give me time. I'll figure it out with Tom about how to share these files with you. Okay, thank you. All right, so let's just, running is very easy. Control Enter. Okay. Oh, I had 3.9 in my system laptop, but Google has only 3.7. That is good enough. I'm just telling you how to find it. It is always important to know, when you move between systems, you want to know what the difference is. Okay, because otherwise you will not be able to solve some problems. Okay, so here is there are few data structures in Python. One is called list. Please write it down, note it down. List. The other one is dictionary. Third one is set. Fourth one is tuple. These are the only 4 basic things you need to know. Okay, and this all these 4 things are separated out. You can identify and immediately I understand whether it is a list, tuple, dictionary, or set by the following notation. If you have left parenthesis, square parenthesis like this, square parenthesis like this, and whatever you put inside with a comma is a list. Okay, the same thing if you put it with this one, it is called a tuple. With this, the difference between list and tuple is that list you cannot, tuple you cannot modify. Okay, list you can modify. Sometimes you want modifiable collection of items sequence with position numbers. Sometimes you don't want it. For example, when you're working with security issues, you don't want the tuple to be changed by any chance. So you need 2 different data structures. That's why it is. Okay, so let's keep this as a list because I wrote it as a list. Okay, so but list can also have mixed up data types. This is a string, ABCD. This is a number, integer. This is the floating point. This is again string, and this is the floating point. Okay, so it can have mixed. The other thing is in list, it is an internally identifiable what it is based on the location. The location is always starts with 0. So Python always starts with the index. Any index Python will start 0. 0. This is the 0th position. This is 1. This is 2. This is 3. This is 4. So if I want to pick out John, then I have to say list of. Okay, list of means you put the square bracket like this, right? List of means list 1 of, what is that one number? The position number is John, position number is 3, right? Is it correct? 0, 1, 2, 3. So if I do this one, it will print John. That means it is, if I want to access John and then work with that string, then I have to say this one. So this is a list. List is separated, identified by this boundary notation, and the members can be identified using the indexing 0, 1, 2, 3, 4, 5 like that. You can modify this. You can add, subtract, all those things you can do, but not tuple, right? And you can when you remove things, you can remove by a position, or you can remove. Sometimes you want to remove the front and back, right? Specifically because some algorithms need this kind of operation. That's called pop. Okay, and then insert. You can insert and pop. Okay, and even in the popping, there are many methods are there, so I won't go into details. But this is just pops means it will just pop this one, last one. You can also pop a specific one. That's where this index you put here. Okay, So that's what this means here, and the output is here. Okay, and so let's run this one. See what happens. Okay, some problem. What is it? Type object is not subscripted. List of 3. Oh, list 1 should be list 1, right? There is no list there. That was the problem. Okay, so it did that. Now let's do a little bit of work on the pop. There are so many things you can do. This is a floating point 70.2. That's what it says. Okay, there's a better way of printing it out. No concern about that. Okay. I will introduce print also later on. So we are still okay, fine with this. So there is a print. This is about a list, right? There is another one I want to introduce you. Okay, that is called dictionary. The difference between list and dictionary is that dictionaries are like name given to the members of the list. Suppose I give this is x1, x2, x3, x4, x5 name. I give a name instead of identifying it by index. I can identify it by index or I can identify it by name. But if I want identification by name, then it is a dictionary. It's like a dictionary name value, right? Or key value or the word value. Value is the interpretation of the word, right? Similar to a dictionary. Okay, so it's a key value pair. It's the terminology people use is that's a key value pair. Okay, and of course the both. That's the only difference. The beautiful thing about dictionary is that because even if you change the order of the elements because they go by key value pair, it doesn't matter. But if you change inside the list, it matters because when you ask by the same index, now it will be a different value because you change the order. But that's not a problem with dictionary, right? Because they go by key value pair. That's the second type, very important. So we talked about dictionary and list as well as tuple also. And finally set. Set means similar to set, right? Set doesn't have any ordering. That's all. There is no index there. So these are 4 basic types of data structures you use in computations. Okay, and that's what this one is all about. But more, equally important, the next one I'm going to talk to you, what is called the computations within the boundaries. Okay, so this is the list. You can see that, right? This is the list because it has a boundary. I don't even have to say it is a list, right? This boundary is it's a list. But what I'm doing here is that, so I'm doing some computation inside that. It's a looping computation, but I do it, inside the boundaries of the definition of data structure. In this case, list. Okay, so what I'm doing is you take any number in the range between 1 to 11 and then multiply it by 3 and then create the outputs and give me as a list. That's what I'm saying here. Okay, one more time. You take any number in the range. So range is it will start giving 1, 2, 3, 4, 5, up to 10. In the range function, the last number will not be put. That's how this is defined. Okay, again, as I said, indexing always starts with 0. The range function, many times this kind of functions will not have the endpoint. Okay, that's why it is not computing for the 11. So if it computed up to the 11, inputting 11, it will be 33, isn't it? Because 3 times 1 is 3, 3 times 2 from this range coming is 6, 3 times 3 is 9, and so on. But stops with 10. But the point is, it's a beautiful computation inside. Very simple, quick way of computing inside a loop. You can do that, or you can do it with inside the dictionary also. You can do it with respect to the tuple also, and set too. You can do all those things. These are called comprehensions. I don't know for some reason they use this word comprehension. Comprehension means doing the computation inside your structure. This is called list comprehension, right? Equivalent. Otherwise you will end up doing this kind of large computation, and in which you are using a loop called for loop for x in range 1 to 1, 11, and then you have to use this. It's a kind of implied, implied collection of the following is a collection of statements. That's what it says. And then interestingly, Python has this indenting procedure. You see this one, 3 indents, and then 4th one starts. When you have a collection, it will indent automatically. So I didn't do this. Automatically, when I put enter here, it went to the 4th position, because that's how it distinguishes itself, the collection of statements, right? It goes below. This for loop has to be done until I come to the next statement starting from 1, okay? Or it can be like this also. But the moment it sees this one, starting with 1, it means the loop is ended up. So the loop is only 2 lines. I could have more statements there, but the loop ended there, 2 lines, okay? So you can do, otherwise, if instead of doing the comprehension, inside the computation so simply, you will end up doing this kind of many statements based. Okay, there's something about list, enjoy, how to print, all those things are here. Okay, you can do that. So this is about tuples. I already talked to you about tuples. And then dictionary, right? We talked about dictionary. If you click, whenever it's a hidden, you just click on the, this place where so maybe it is here, right? So for example, it says 6 cells are hidden here. If you click here in the open space, it will open up those things. If you do this one, it will execute. If you do it here, it will open up. So, okay. Now, dictionary, quickly. So here is a dictionary. It says name, John, age 35, 1, obese status is 1. You see this one? It has a key is name, value is John. Key is age, value is 35. Key is 1, value is obese. Okay, 1 means obese, that's what it is. So this is called a dictionary. Interesting to see this one, the boundary, how the boundaries are differentiated from the list. It's a double bracket. Some people call it double brackets, squiggly brackets, right? And no, so dictionary has its own functions also. So, and you can call each of these, keys and values by using very specific functions. So dictionary 1, okay, I want name only. That's what it means, dict 1. So it says, okay, print dict 1, name is, and prefix, and then dict 1 name. Oh, dict 1 name is John. And dict 1 ages, and then this backslash within quotes means go to the next line. Backslash within the quote, you can do that, okay? Go to the next line. And then dict 1 ages, and then dict 1 age. That means dict 1 age is 35. Oh, so it's a dictionary name. Name is John, and the age is 35. So you can print, access, and work with that. And then you can also find out, just what are the keys are, what are the values are. You can do all those things. So here, dictionary keys only is this, okay? Dictionary values only this. I am printing, print dictionary 1, that is this one, dict 1, and print dict 1 keys only. That's what this one is. Print dict 1 values only. This one is. And then print dict 1 dot get one specific key. Oh, its values base. Okay, things like that you can work. And here is a quick, it's a very interesting print facility. How to lay the print values, with a certain number of, range of values you give. So 6 places I want to give. Okay, that's what it means. Print. I mean, I was asked to, by somebody to, hey, can you give me all these possible values? It will print out. Is osteoarthritis, no pain, all those things. Okay. So some combinations they wanted. I showed them how to do that. So it's I have to use a combination here. For loop for I in OA yes or no. So I'm taking about for I in OA yes or no, which is it will take this value, this value. For J in OA pain chronic. So OA pain, osteoarthritis, pain chronic, no pain 1 to 3 months, no pain 1 to 3 months, pain greater than 3 months. Okay, these 3 categories. I'm rotating all these cases, right? That's what this loop is about. And finally, other pain chronic. That's another list. So I'm just printing these values as a loop going through using this print. And print. This is called the print facility for the Python. I'm using 16 position to do this one. I'm giving 6 position for the first one, 16 position for the second one, 20 position for the third. Okay, that's what this means. And then I am printing IJK. So I use print facility. I use the loop. Okay. So basically, you will learn these things. You can learn these things. My point is, you can run it in a Colab. Now, I want to go to having introduced this one. Let's see whether we can understand how much we can understand. Otherwise, I will also explain some of it. But the point is, you should be excited now that, oh yeah, I can do Python. And the moment you feel that way, go to Colab, experiment yourself, use the Jupyter Notebook, use basic Python. I introduced 4 data structures, and I introduced for loop, and then I used comprehensions. That's a great start. Okay. As I said, we can do some other teaching on Python later on. If there is more interest, we'll come to that. But here, in this example, we are talking about basically fetal health status. Okay. And I went to the Kaggle, remember that, okay? And from Kaggle, I can move this to Google, okay? Also remember that, okay? It says here, I can store it in GitHub. I can upgrade to Google Cloud AI notebooks. You see this one, right? I can take it from here to Google Cloud. And from there, I can run through the Colab. I can add or upload data additionally, editor types, all those things. So it provides you all facilities to move between Kaggle and Google Colab. So we came here. So you need to always download the packages you need, and then sometimes you use alias because you use so many times. You don't want to type pandas. PD is 2 characters versus this is 6 characters. You save so much time. It is, believe me. Okay, it may look very simple and possibly silly. Oh, really? Just typing this at the same time? Yes, because you use so many times. You don't want to repeating this. Sometimes the package names are big. Look at this one, right? Train, test, split. I know you may not use that many of times, so you don't need a alias. But NumPy is a heavy vector-based computations. So you will use this and pandas and NumPy, matplotlib. That's why it is PLTS alias. Seaborn is another visualization tool package. That's alias is SNS. Plotly is another visualization tool. So package, and you use it as PX. Plotly Express. Okay. So here you read this. This is the command pandas dot underscore read underscore CSV. Instead of reading it from Kaggle internal server, you can download this and read it in your Google Colab, right? So and then that is called the data frame. Actually, usually we will put data, but you can put any name, right? So data set, we call it data set, data frame, which is the data frame, right? Data frame is where you can include both qualitative variables and quantitative variables. That is the benefit of data frames, and this is called data frame. That is another data structure, okay? But it's a data structure coming through pandas. And if you put this one ds info, it will tell you the data info. I didn't read this one. Sorry, I should have done all these things before I go there. Okay, so I'm going to run this, and after it is run, so until it is run, it will wait. This one will wait, even though I put it so it hasn't finished. The moment it is finished, it will come here. It will run all these things, bring all those packages into the Kaggle server that is assigned to me graciously by Kaggle. Right, and it will read this one, right? The data. Let's wait until that one. Oh, there is some problem. Wait. Some issues are there. What is going on? So it ran. What happened? Oh, I didn't allocate. See, this is the accelerator. I have to allocate. I'm going to allocate GPU. So I'm going to use up time from my 37 hours. I already used, I already used 3 hours. Really, 10 hours I used, because 37 hours. 27 hours I have, so it's okay. I didn't do all those things, so why will it work? It won't work. Now, let us run this one. It may take time to start. Let's see. Draft session waiting for Jupyter. So it won't take much time, don't worry about it. It will come through. So it is set up the system now. HD hard drive set up, CPU, RAM, GPU, everything is set up now. Session started. Maybe I should redo it now. Now that session started, so it's done. So it just said that okay, the data is here. Okay, that's all it said. Now I want to import all these packages. It's running now. Okay, it ran. It's done. Okay, no errors. Let's see. Okay, now here you go. The data. It says what the columns. What are the data types? These are all floating points. Floating point means the decimal integers. Okay, integers, decimal based numbers. Decimal based means point and something, right? And baseline value, accelerations, fetal movement, uterine contractions, light deceleration, severe deceleration, prolonged deceleration, abnormal short-term variability, and so on. Histogram, number of peaks. These are all the data points that we have. These are data columns. These are attributes. Okay. And then I want to see just top, these are commands you learn by practice, you learn. The top 5 or 6 observation I want to see. That's what it means here. But why here we didn't? Okay, I don't know, for some reason it didn't run before. I probably touched in between when it was running. So it was just printing out the top 5 rows. That's what it means. There are 22 columns are there. These are the columns of the variables, and top 5 rows are there. So this is a very simple command that tells you. You also have tail, ds.tail. If you put the bottom commands, that is here. Bottom 5 values will be there. Okay, so here it is. So I can also see shape, how many rows and how many columns are there. That's what this one is. This is 2,126 rows are there. That many samples are there. And there are 22 plus 1. Is it 22 plus 1? Wait, or no, 22. 22 columns are there. 22 variables, 22 columns are there. Okay. And I'm just doing some duplications. Is there any duplications there? There are 13 duplications up there. Okay, really? Okay. So anyway, it is there for some reason. So we want to drop those things. That's what drop duplication means. Now I want to check the shape. So it should be less, that number 13. That's why it is 2013, 22. Any questions now? Please, this is the best time. I'm kind of now jumping into the analysis using Python. I hope you are all encouraged. How many of you did not have Python exposure so far? Please raise your, put your message here, please. I'm just curious to know. How many of you did not have Python experience? Quickly, please. Okay. I'm just curious. There are, I don't know how many people are here right now. Maybe. Okay. So there are at least 4 people. Only 4 people. Rest of them know Python. So you're all good. If I jump quickly to need to know. Okay. Jump quickly to the other exciting things. I want to walk through, but I'm just telling you. Okay. Need to know. Okay. So so I hope you are encouraged to learn Python. Remember, now in this new modern world, even CEOs have to know programming, because it's not about Python or R or anything. You will be able to ask good questions with your analysts and the algorithm developers. That's the only reason. Okay. So, and it's not difficult. Just spend time, repeat few times, you will be fine. And you can claim, oh, I know Python language. Right? So all these things are, you can do frequency counts. You can use the command called value counts. Okay. One question: how do I tell if I shall use a linear algorithm or a non-linear algorithm for the data I'm working on? Okay, so first of all, when you say linear algorithm, you already set your mind about regression. Am I correct? And when you say non-linear algorithm, you are thinking about classification, logistic regression. Is that correct? Or clarify for me. Okay. Oh, it's Mike. Tom, you were asking that. Okay. So you can answer now or later. All right. So linear. So when your outcome is continuous, use linear regression. Which is the linear outcome. Okay? Use when your outcome is continuous. Use that. When your outcome is qualitative, you have to use more advanced models like classification, which are typically non-linear outcomes. But even for continuous outcome, you can use even for continuous outcome, you can use non-linear models. Okay, so just because it's continuous outcome doesn't mean that you have to use linear model, linear regression, linear algorithm. You can use non-linear also. So if the linear algorithm is not suitable, because if it is, for example, if your outcome is continuous, but it's an index, integer value, count value, few count value, like 0, 1, 2, 3, 4, 5, 6, like that, only that much. Then it is what is called a count model. Then you have to use a Poisson regression, which is a non-linear algorithm. So, or if you want to use classification, it's again non-linear algorithm, because you will use logistic function, which is a non-linear model. Okay, or if you use gamma or exponential model, all those things, then you will use geometric regression. You will use, they are called nonlinear regression. Then you will use nonlinear regression model, even the variable is continuous. So I hope that answered momentarily, right? We can always talk more. So there are more things here. No, there is a for loop here. You remember I introduced for I in dscat. Okay, dscat is this one. dscat is a subset only. So we are taking only these 4 or 5 variables. What are they? 1, severe deceleration, prolonged deceleration, histogram, number of zeros, histogram tendency. These 4 variables only we take into consideration, and that is what this means: subsetting the data set, subsetting the data set. You put that list, whatever you want, it's a list, right? What do you want inside that one? That becomes a subset data that is called DSCAT. I think it's categorical variable, something like that, right? So here is some program, histogram I can show, I can see, and then so now for these variables only, I'm doing this for loop. What am I doing here? I'm going to print the histograms, right? Plot figure is 15,6 size. Count plot, it is really a count plot that we are going to do. So let's do this one. Okay, so I'm going to run these few things here. So there are many ways to run this: run cell, all before, all after, all everything. We have all those controls here. So I'm going to do all before. Okay, sitting here. I'm here sitting now. What happened? I want to show that, right? So it was reading. Oh, it ran everything. Okay, fine. It's fine. So DS describe. Describe is a it's a summary, basically doing the mean, standard deviation, minimum, 20 percentile, 50%, 70% maximum value for each of the variable for continuation, right? For each of the variables. That's what it's doing. Describe is the command you have to use. If you want a summary, you want to find out, how many of the, unique values are there, right? So baseline value, there are 48 unique values are there. Acceleration, 20 unique values are there. Like that. These are all unique number of values. You want all these things. This is n unique. Okay. This is this. Okay. This is count. This is the count n unique for continuous. Okay. This is the fetal health unique. That is only 1, 2, 3. Okay. 1 means I think it's normal. 2 means suspect. 3 means target some situation, health condition situation status. So we find this one. Select this particular for this particular variable. You want to find out the frequencies. That's called value comps. That's what this means here. And then I want to do the histogram. I ran everything in one shot. So this is what the histogram is. I will give you momentarily. So there is some EDA you have to do. I will give you 10 minutes at least, or 15 minutes to ask questions. Don't worry. Let me finish this example. So these are all called EDA. Exploratory data analysis. You want to check all these things. Okay. Again, there is a loop going on here. Loop computation with the pictures. SNS is about picture, swarm plot, and box plot. It didn't run that. These things were not done. Okay. So below, from here onwards, I'm run. Okay. So I can select, run after. Okay. So after this, it's going to run. So you ran all these things quickly, all these things, right? Box plot is useful to understand some outliers. Remember that. Okay? It's very, very important. There seems to be too many of them. Beyond that, beyond that that outline boundary. One here and so on. Okay. Now let's do the again, some more plots are done. It's taking time, but what it's going to come down is this one. Remember that train test, that business is coming here. So this function will select 20% for test, remaining 80% for training. And there is this data set, you can split in one shot, train test split does in one shot, creates X training, and that, its corresponding Y value, that's a dependent variable value. Okay, that is a 1, 2, 3 case. And then test value, the X values, that's the independent variable values, rows, and then their corresponding 0, 1, 2 values here. Okay, so you do that. After it is done, look at this one. We are doing logistic regression, decision tree. Many times we will do multiple models, right? Random forest classifier. SVM is called SVC here. Okay, for some reason they call it as SVC. It's okay, classifier. Okay. I made a complaint about this, but anyway, that was a long time back. I wasn't doing Python at that time, but I saw this one. I thought it's strange, but that's a problem, right? People use different words sometimes. So I want to do, I want to predict using all these 4 things and then create confusion matrix. Look at this one. Confusion matrix is coming. Okay. So I will let it, confusion matrix is what is here. It's a heat map is also there. This is a confusion matrix. It will, print all the confusion matrix. Also the precision, recall, all those things it will print. Let it come. Let me take the questions here. I can. Okay. While that is finishing, let me take the 7 points. Use the same Zoom login link as today for tomorrow's session. Okay, that's okay. Direct message. How do you tell? Okay, that I will. Thank you. It's easier to see output than R. Okay, I am converting here some people. Hopefully, but we have no choice. Now, if you want Python, advanced AI, Python has a lot of things to offer. Okay, will we have access to the slide? Yes. Give me time because I'm kind of consolidating these slides. So definitely after Thursday, tomorrow, right? That's the last day for me. But the whole program is going on for the whole month. Okay. Hello, I would like to know if we could have access to yesterday and today's slides. Okay, thank you. Give me time for this, please. Okay. I petitioned that somebody will provide slides at the end of the workshop. Yes, I do plan to give the slides. I can provide with the recording of today and yesterday's workshop. Like, okay, that's a comment. How do we know we are splitting the desert for training and testing? Oh, that split 0.2, right? In this case, it is 80-20. Does it answer here? Yeah, it's 80-20 in this case. Yeah, exactly. You already answered this. Somebody, yeah, SK answered that. Thanks a lot, SK. So it is still taking time, sometimes, it's even though it is GPU, it is taking, I'm kind of a little bit surprised, but I don't know why it is taking, because it's a very complex plot, that's why it took time. It's all complex plots, right? So some very sophisticated, interesting plots. So give yourself some time. It will come back with the answer. I didn't show, store the answers, So if you want to store it, you have to say save version. It will execute it and save. That's another thing, It will not say what you have current. I made that mistake. So I ran this large program, executed it, thinking that, after the execution, I can say, no, you have to start with save version. Then it will ask you whether you want to execute and save or a quick version, which means just the code alone. But I want to output, because sometimes when you run a large program, you want to save the outputs, intermediate outputs, the final outputs, right? It's very important. That's the benefit of saving the output. That is, you don't have to run for the outputs again. So, any questions? This is the best time to take questions. Now ask me all kinds of questions, because we can see the results before we split for the day.
And does anyone have any questions? We will have to, because we're over time just a little bit. Any questions really quick before we end?
There is one. Thanks. Having the recording would be great too. Okay. Sure. We'll do that. Can't wait for tomorrow. Okay. Thank you, sir.
All right.
Ben, thanks.
It looks like there aren't any questions, but I think a lot of people are excited for tomorrow. So thank you so much, Dr. Samba. Again, I cannot thank you enough. And really excited, looking forward to tomorrow. And we'll send recordings out to everyone who requested them as well.
Sure. And this output, I will save it and send it to you also. Okay, that's another one too. Okay. Thank you, Ms. Sarah. Thank you, Sarah, and thank you very much. Professor Mahesh, but Mahesh, full name, I don't know. Okay, thank you. Welcome. Great. I'm really happy that I could. Some of the strategies I'm sharing with you, believe me, it takes a lot of experience, background experience, and literally sweat and tears, right? Honestly. So kind of like what I'm saying, just use Colab and Kaggle. And Kaggle has tons of data science projects to try and learn from others. And Google provides you tons of connectivity between Kaggle and Google resources, Colab resources, Google Drive, best of the world. You don't have to worry about updating. That's the major problem is syncing these packages. It doesn't work easily, believe me. So thank you very much. Welcome, Lee. So I don't know. It's up to you. If you want to stop, you can. It's up to you, Tom. Because it's working. Continue to work right now. It's taking time. It should not take a lot of time, but it is taking time. So I would say those who want to stay put with me, you can stay with me. Otherwise, it's you make the call, Tom.
So I'm actually going to jump in here. This is Katie. Unfortunately, we are going to have to wrap up and close things out. We have another webinar with the same account immediately following this.
So what I can do is how about I put my personal personal link here. If you don't mind, give me a moment. I'll give you my personal link. You can join that, go to meeting, and I can show you the results. Or how about this? Don't worry about it. I don't want to keep you waiting. I'll run this, share it with you tomorrow morning. Thanks a lot. Have a great
Perfect.
day, everyone.
Maybe we can start off with that. Thank you, Dr. Samba. I really appreciate it.
Wonderful. Have a wonderful rest of the day, everyone. Bye-bye.
Bye.